So that we stay in schedule. Welcome to this final seminar of the Finnish Ecosystem Observatory Fair. My name is Hanna Asikainen. I'll be your host for today. I hope that you all had a chance to get a little bit of coffee and your trip here was okay. Lovely to see so many of you here in beautiful Suomenlinna. And also welcome to those who are following us online. The whole event is streamed on YouTube on account Syken Webinaarit. We also have Aapa and Peter following the chat there. So if any online audience members have any questions, please do ask them. And we'll have a few Q&A sessions throughout the day to hear from all of you as well. I know that you're all very eager to get started with our wonderful keynotes. But just a few practical things first. I think all of you now know where Myllysali is on the other end of this building. This is where coffee and lunch are served. And also the closest toilets are, if you go outside that door, downstairs, and outside on that alleyway, there are two women's and men's toilets there. This morning, we'll focus in on global and European biodiversity observation systems and hear from a few different perspectives. Before we break for lunch, we also have a short video performance, an art video performance. And then after lunch, we dive deeper into the 4 years of work and results of the Finnish Ecosystem Observatory and hear directly from the different work groups here. We'll try to finish today by 4:30 or just before that. And obviously then there's the after party in the evening, but I'll tell you more about that later on. But now, I'm sure that you're eager to get started. Our first speaker today is the Director General of the Finnish Environment Institute, Syke, Leif Schulman. Before his current position as Director General, he was the director of the Finnish Museum of Natural History for almost 11 years. And before that, he worked as curator and director of the Botanical Gardens of University of Helsinki. Leif holds a PhD in biodiversity sciences, and alongside his background in research, he has devoted much of his career to developing research infrastructures supporting biodiversity research, such as collecting and IT systems nationally, within Europe and globally. Please welcome to the stage, Leif.
Does it work? Good morning, everyone. Wonderful to see that there are so many people convened here today under this 18th century vault. Allow me to start with a brief walk down memory lane. As mentioned, I've worked for almost 30 years with the description, cataloging, and listing of biodiversity. Although not perhaps in the traditional biologist's way, I have never been a very keen bird watcher or collector of insects or anything like that. Rather, I've worked with enabling biodiversity monitoring, description, cataloging, and so on. Developing tools to make it easier and faster to do these tasks. So it started with computerized identification tools, went on to planning databases, collection management practices. Later on, I spent a good 10 years developing the Finnish Biodiversity Information Facility, FinBIF, which mobilizes and collates, integrates data and distributes it for research and administrative purposes. I was also involved in GBIF, representing Finland there for about 10 years, and so on. Throughout this work, although I've seen a lot of progress, I mean, wonderful things have happened. All these online databases that are available, of course, seeing GBIF growing from a mere vision to something of tremendous value for biodiversity research. so there's been a lot of progress, but throughout this time anyway, I think there's also been a strong kind of nagging feeling of failure. A feeling of doubt that we are not doing enough and we are not progressing fast enough. And not only this feeling of failure or doubt, but there's also always been a nagging feeling of envy. Envy towards our colleagues in the realms of physics, astronomy, these hard sciences, where they've shown incredible success in joining forces, pooling effort, and managing to mobilize, well, astronomical sums of money to build the infrastructures that they need for their research. And I've always felt that we are not, matching their success. And then it's also led to the thought that why is it that we are ready to invest these astronomical sums into looking for life that might exist somewhere in the universe, and then we are putting only pennies into studying and monitoring, describing the life that we do know exists on our own planet. Well, there are certainly several reasons. It's admittedly a different task to look at in detail at the life around us, comparing to scanning for a few electromagnetic parameters in space. But it's probably also that there simply hasn't been that kind of technology that we would ask for. You know, we don't have anything or haven't had anything equivalent to that you see here on the screen that we could lobby for. Obviously, also, there's always been a lack of interest in biodiversity on Earth. It's sexier to look for extraterrestrial life than to study the life around us. But now I think that we are actually at a turning point. Now that finally, in the last decade, the technology is emerging that, well, maybe not quite these huge telescopes, but anyway, technologies that allow us to speed up our inventory of life and the monitoring of life, such as environmental DNA, camera traps, Earth observation. So finally, we are in the technological position to advance more rapidly. And at the same time, all of a sudden there is a surge of interest in biodiversity. All of a sudden, society at large, the private sector, is really longing for and craving for better information on biodiversity. So now is really the time to rise to the next level. Maybe not, as I said, trying to find these huge silver bullet technological investments, but at least trying to come together, develop standards, make concerted efforts globally towards the common goal. So something perhaps instead of the gigantic telescope, something along these lines. And this is exactly what the Finnish Ecosystem Observatory represents. And that's obviously why I'm so happy to be able to work now as an enabler of this kind of work. As you will see, the FEO project has already achieved a lot of wonderful results. But I would also want to point out that it's not just the actual outputs of the project, but it has also been a start point for a national process as part of the international processes going on, where we have seen actors come together and kind of gather around the same vision and sharing a will to go forward and to rise to a higher level compared to where we have been so far. So with these words, I wish you warmly welcome to this event. And I want to point out that we at the Finnish Environment Institute do not only share doom and gloom pictures where we want to build hope with research. Thank you.
Thank you for these beautiful opening words. Next up we have Laura Höjer. She's the research director at Finnish Ministry of the Environment. Laura works in the management support of the ministry directly under the permanent secretary. Her duties include coordinating the ministry's foresight and research activities. I think no further introduction needed. Yeah.
Thank you so much. Thank you. It's great to continue from after Leif's excellent presentation. Maybe my topic doesn't sound so exciting, so it is more about science policy arena and national perspectives to this. But I did want to start with nature data and nature information, and it's good continuation from Leif's presentation. So I think at least now with this FEO project, we can say that we are pioneer among European countries in terms of coordination of nature monitoring and information management. And I'll be working also with biodiversa, and I think it's really great that now the solutions created here can be widely followed and replicated at the European level. So it's a great continuation. And I want to emphasize now with these luonnontila indicators that they really serve the society broadly, as Leif was actually referring to, that for example, the business life, the companies, they really now want to have the data and do nature work and then follow sort of, want to have indicators and follow up the work. So not only nature, but also society and the economy benefit from the investment in this high-quality nature data. I think we need this data to prepare wisely for the future. So we are a very important topic, maybe the most important topic in life that we are dealing today. But then maybe something about the R&D sort of landscape now in Finland. Well, a lot of discussion now, all the Finnish people know, like we are talking about money so much today. Not maybe everybody, but yesterday it was quite hard day, a lot of budget decisions, a lot of budget cuts in Finland at the moment. And that's why we have been, for example, this morning, I think I've only been talking about this issue. So that shortly, there is going to be scarcity of resources for all the ministries, for all the sectors. So it's not sort of specifically to our ministry or to environmental sector, but the resources are diminishing. And I think that really emphasizes the cooperation between different actors, how we influence the R&D funding, so that we can get funding to the topics important to us, and how we use the information produced. So very much of the topic today. But then luckily, there is a positive side. So maybe the only sort of investment at the moment is R&D investment in Finland. And luckily that still stayed. There was some excitement yesterday that are they going to cut this R&D investment, but we still have this. And for example, there is now, thinking of the topic today, there is going to be more money now to infrastructures at the Research Council of Finland. And I can see that's hopefully a very natural continuation, of course, tough competition, but I'm sure this topic will do well there. So there is now more, for example, funding for infrastructures in Finland. So it's good that there is also some positive news. But maybe something about the landscape where we are working at the ministry. Is it? Yeah. So, of course, for us at the ministry, the Finnish Environment Institute is the very important research institute to us, connected to us there, and then the other research institutes producing scientific knowledge, and of course universities. Then a very typical feature of Finnish, the science policy landscape, is different science panels. Very close to us is climate change panel and nature panel, and Syke has a big role there. And then we have this new Sami Climate Council, which I think is really important and interesting. And then also we have expert panel on sustainable development and on forest bioeconomy. And then we have this, on the blue, we have those sort of science policy interaction actors, Forum for Environmental Information, that I think has done actually a lot of collaboration with FEO projects also. We have had sort of events together with this institute, and then we have, for example, Finnish Academy of Science and Letters. But then sort of we have a radar there of different funding instruments, and as I said, now when the funding is going down, is really just more important to try to influence that funding, that we get funding to this direction, also to the topic of today. And in the radar, there is sort of a logic in the picture that the ones closer there are the ones we sort of have some influence on as our own funding. But a lot of different kind of instruments, I guess many familiar to you. And of course then important different close collaboration with different ministries and different R&D funders and universities of applied science and different, of course, on the private sector interaction. We just had about 1 week ago, we had this workshop where we were discussing on how to develop now, especially looking at the landscape. We have these sort of difficulties with budget cuts, but then we have these R&D investments, how we can collaborate together. And maybe just few findings from there, maybe related also to the topic today. So I would say that these problems we are working with, ecological sustainability crisis, they are very knowledge-intensive problems, a lot of uncertainties, and no easy solutions. So we need very system-level transition. And of course, wide array of different scientific disciplines, and I think one important thing is sort of this, that we should not think this scientific advice is something that you inject to some policy process in an optimal moment, but it has to be sort of integral part of the processes throughout. But I think I was running out. Oh, yeah, so 1 minute. But yeah, maybe I end with this invitation. So if you are interested in science policy, this dialogue and this topic, so we are going to have a very big conference in June in Finland, SRI conference, and there we are going to have a topic on the same sort of, on the science policy dialogue, and it's going to be an open session, otherwise this is sort of not an open, but this is a free session, everybody can join and also watch remotely, and we have Eva Brimmer from Syke there also on the panel. I was actually looking, I couldn't, 1 minute, yeah, I thought it was earlier, so I've tried to hurry up a little bit. But yeah, this is about the R&D landscape, and once again, welcome here, and as I said, the most important topic we can have on this nature data, and looking forward to the discussions and presentations today. Warmly welcome.
Sorry, some technical difficulties. As you can see, the screen is kind of flashing a little bit, but we'll try to figure it out. Thank you, Laura, for opening up that. Next, we have a very interesting guest come tell us about the global biodiversity observation systems. Andrew Gonzalez was born in the UK and lived and worked in Montreal, Canada for 20 years. He is professor and multi-year chair of biodiversity conservation at McGill University. His lab works on ecological and evolutionary dimensions of biodiversity change. Before that, he was assistant professor at the University of Paris 6. He got his PhD in ecology from Imperial College in the UK. Today, he is the co-chair of GeoBon and the co-director of Quebec's Center of Biodiversity Science. In 2018, he co-founded a consulting company called Habitat that offers biodiversity science to many clients, including NGOs, cities, government, and businesses. Please welcome Andrew.
Thank you for that kind introduction, and hello everybody. It's a pleasure to be with you today to share in this landmark moment. We have the FAO, the Finnish bond, and I think it reflects the remarkable contribution of Finland as a whole and the scientific community to the global effort that GeoBon is trying to bring together. So my charge today, to go back to the title here, is that we are at the start of, we see a new horizon here for biodiversity science. Never has there been a greater investment in biodiversity and the sciences associated with biodiversity, and what that information and that knowledge means for society. That the way that we can observe the impacts of humanity, both negative and positive, and how we can mobilize that knowledge to share the solutions. How can we mobilize that knowledge both within our own countries, like the FAO, but among countries, as we recognize the increased globalization and interdependence among countries, both in what they benefit, what they share, and how they impact the state of the Earth. So I want to start with a map. Maps are fascinating. The colors of this map are striking, and it's easy to spend a lot of time talking about this map. It captures a lot of information. It's actually telling us about the gradient of biodiversity intactness. What is the fraction of species remaining on those locations? And the warmer the color, the smaller the percentage remaining. So we go from 100% down to 60%. But this map tells another story. It tells a data story. It tells the story of 2.6 million records behind it. Just think of that, 2.6 million observations done by ecologists. Even if each observation was $1, that map would have nearly $3 million of value, a capacity to inform decisions worldwide. But what if it actually cost $10 per observation? Or $100 per observation? Now we're starting to get to the telescopes we're talking about. We're talking about a map that's worth potentially hundreds of millions of dollars. And this is just one measure, one way of capturing the human influence on the state of our planet. And we can clearly see the imprint or the fingerprint of humanity through where we grow crops, where our cities are, etc., etc. So I want to impress upon us that, yes, there is a revolution going on in the technologies of the way we observe nature and its biological diversity, but now is the moment to come together to share that information and knowledge so that we can produce the kinds of knowledge products, if you like, that will motivate our commitments to the global biodiversity framework. This was a landmark, if you like, in the biodiversity world. In December of 2022, the parties to the Convention on Biological Diversity came together in Montreal to sign this agreement. This new agreement with 4 goals and 23 targets that are designed to bend the curve of biodiversity. That if we can characterize the global trajectory of our planet, we want to be moving away from the gray line, right? The business as usual line, which is the degradation of the ecosystems that we saw on the previous map. And we want to be guiding our actions towards the green line here. And of course, the green line is a cartoon, a caricature of a reality that differs from country to country. Now, the great innovation, one of the great innovations of the GBF is that it now has a monitoring framework, that it holds countries accountable to describing their commitments, the way that they are going to observe the state of nature, and how they're going to report on their progress. This is crucial, because if we don't hold countries accountable, if we don't ask them to convey the results of their actions, then we won't know which curve we are on. Now, this on its own is boring. Just reporting progress is boring. What we want to be able to do is use the energy and the investments in the monitoring framework to guide action, to set us onto a different pathway. So this is monitoring for action in a way that maybe historically we have not been as good at doing. That we think of monitoring mainly for natural resources, and we haven't broadened the scope of how biodiversity should be monitored to contribute to our understanding of change for ecosystems and for people and the many millions of species that we share this planet with. So what we have is the emergence of a science policy bridge in biodiversity science. On the left, we have the observations, the growing millions, if not billions of observations that are accruing every year. That monitoring and reporting contributes to the, that shouldn't be happening, to the science policy interface between the UN Convention of the CBD, but of course as well the UNFCCC is increasingly interested in biodiversity, and we have the SDGs. And we have a new-ish 10-year science policy platform that synthesizes the knowledge of many hundreds, if not thousands, of researchers. And this provides guidance on what to do where. And in this context, it's the observations that confirm and validate that we are doing what we think we should be doing. And my particular vision for today is that no single country can do this alone. That even a wealthy country needs friends. That we need to be able to share that knowledge and understanding of how biodiversity is changing regionally, continentally, globally, because it's a single biosphere that does not recognize national boundaries. And we also have to recognize the sharing of the solutions, the understanding what works in one place might work in another, or vice versa. And so there's this opportunity to create a global system that allows us to share the knowledge that's going to get us to bend the curve of biodiversity. So what does that science look like? This is what is captured by the FAO. Is this recognition that biodiversity changes, the way we understand biodiversity change varies with the scale at which we observe that change. Whether it's globally, continentally, at the scale of a landscape, or down to your backyard. And how it's changing depends upon an array of drivers, of human pressures, whether that's agriculture or forestry or urban growth, or the way that we extract resources from our coastlines or from our forests. Those all impinge upon nature in this complex combination of interacting forces. But we now have modern biodiversity science. We have the constellation of satellites that allow us to take images at different wavelengths to understand how the Earth's surface is responding dynamically day to day, minute by minute. And GeoBond has worked to standardize the complexity, to help us gather these essential biodiversity variables that allow us to understand how biodiversity from genes to species and populations, the composition of communities and ecosystems, and the way those ecosystems function, and the services that we get from them. And it's the understanding that we get by going from left to right, how we go from scale explicit understanding of the different dimensions of biodiversity that allow us to assess change locally, at the smallest scale, regionally, and on up to the global. And so the scientific vision is about crisscrossing the scales, aligning the observations with the decisions that we want to make and the trends that we want to change. And so what the countries of the GBF have to do is fill this gap. On the far left, we have national monitoring systems like the FAO being built daily. Increased interest in building biodiversity observing systems. There are communities of people working together in different sectors. And a country has to report its progress to the global commitments under the GBF. And so what we have to do is fill the gaps. We have to develop the data infrastructures, the analytical capacities, the computer models that allow us to calculate the indicators to track our progress and the knowledge that we're gaining to fulfill our national commitments. That's one dimension. Do that in an adaptive way so that we're learning how our ecosystems are responding to our actions. But crucially, we need leading indicators, predictive indicators that allow us to guide action and prioritize and plan and use our limited resources and funding to reach our collective goals. This is the challenge. And there is one missing component in our global system that I alluded to earlier. So our climate colleagues have a global climate observing system. This supports the work of the climate scientists under the auspices of the IPCC in our attempts to reach the goals of the UNFCCC. But in biodiversity science, we lack this global system, this grand vision, this grand infrastructure that Leif was speaking to, alluding to earlier. There is a desperate need for this global harmony, this global effort to build an observing system for biodiversity and to better understand our biosphere, the unique biosphere in the solar system and beyond to the best of our knowledge. And so what this means is that we want to be able to take the pulse of the planet, to understand dynamically how patterns of climate are impacting biodiversity and vice versa, how trade, how economic impacts from country to country mediate biodiversity change and the actions that we impose. So what is this global biodiversity observing system? It's not just satellites. It's not just eDNA. It's not just camera traps. It's the knowledge that we generate with those infrastructures, those observations that we see at the top left, where we have this international collaboration among parties. The international exchange of observations that allow us to generate shared knowledge, that allow us to make the maps that I just showed you with the models and the data coming together. And then the way that we process that data ever more rapidly, to imagine a biodiversity forecasting service. Imagine that. Warnings that allow us to guide action and scenarios of societal change that allow us to map what we could do and the relative costs and benefits, the values that are at stake when we imagine different outcomes and scenarios for people. And of course, ultimately, feeding into our decadal understanding of how we're doing between now and 2050. That is the vision in toto of the GBIOS effort. And we have so much already. This is a movie of the growth in the observations in the Global Biodiversity Information Facility. Let's come back again. In fluorescent green are the accumulation of observations over time. We've gone from a few tens of millions to 2.6 billion, and Tim tells me it's about to go to 3 billion. That's a remarkable source of knowledge. It's patchy, it's spotty, it reflects historical investment in where we go to invest in observations of nature. But new countries are coming online all the time. This is the beginning of that global system, our capacity to share information about the state of nature. So, just a few months ago, we published the blueprint for building GBIOS. It starts with the countries. This is a map of Colombia, but it could be the map of Finland. You have just gone through 4 years of an engagement, assessment, design, and implementation process. You're here today to share that experience. And what it means is that you're producing a systematic, scientific, evidence-based approach to understanding how biodiversity is changing, how you measure that change, how you create a service that provides that knowledge to Finnish society. That service is complicated. We are developing the models all the time and the data infrastructures all the time. But what that means is that Finland is now placed to contribute to the global effort. In a position not only to contribute to understanding what's happening in your country or in Scandinavia more large or within the Baltic region, but also within Europe and ultimately globally. And so what that means is that Finland will contribute to our understanding of trends in different dimensions, these essential biodiversity variables in different places at different times. So, of course, this reality that the bond will be different in every country. There are biocultural uniqueness of every place. The history of how science has worked with policy will vary from place to place. But the bond concept is general enough to accommodate that. What's crucial is the social process that we start out with and how that feeds into the ever-growing and hierarchical need for that cooperation. So in addition to FEO, there are other bonds around the world that are growing. We just received a renewal for the Japan bond. The Japan bond is part of the Asia-Pacific bond, this growing mosaic of countries that are connected together to form a regional network. And there are other parts of the world, in other countries in Europe, or in Africa, or in South America, that are starting to work together to stitch this patchwork quilt of countries to form our global biodiversity observing system. So there are many things we could do next, but there are three that I think would be fun to do. The first is maybe a little bit boring, but it's necessary. It's the guidelines for coordination, a commitment at the international level, at the UN level, to think about how we link our activities to create this network of networks. And by collaboration, developing the protocols that we need for sharing in situ data, remote sensing information, so that we can accelerate this trend assessment. And do that in a way that we can repeat year upon year at a much higher frequency that we're currently available to assess the state of biodiversity worldwide. That is going to be a remarkable thing when we get to that place. And so I just want to close with a question to you. I can't quite, 3 minutes, thank you. There are many ways we can build GBIOS. The 1960s way of doing this would be have a big posh offices in Paris or in Geneva or something, and it would be a very top-down process. And I think that would be an error if we tried to do that again. What we have today is an informal, loose collective of countries that kind of collaborate. Some collaborate more than others. And I don't think that's going to get the job done. I think what we need is to commit to a federated network, a sort of a coalition of the willing, maybe, of countries that are willing to work together to share common principles and protocols, to share the science and to share the solutions, so that we have something that's fit for purpose, that's designed to meet and support the efforts under the Global Biodiversity Framework. That third option, that mid-20th century view of how we create a globally centralized network, probably isn't the way to do this in the 21st century. That countries will come and go. Not every country will stay in the federated network. Others will join over time as the means accumulate. And hopefully, as funding comes in from the public and private sectors, we hope that we will build this systematic observations finance facility. Our climate colleagues have just announced one of these at the previous COP. And this will be helping lower income countries build the infrastructures that they need to contribute to the global biodiversity observing system. And that will be a new world. And we will have reached a new horizon when we know we'll be able to create this federated network that will be the global biodiversity observing system. And with that, I thank you for your attention.
Oh, thank you, Andrew. All right. Next up, it's my pleasure to introduce the Deputy Director from Global Biodiversity Information Facility, Tim Hirsch. Tim has been GBIF's Deputy Director since 2013. In this role, he has also led the participation and engagement team of the GBIF Secretariat. He serves at the advisory board both for GeoBon globally and for EuropaBon project, and has been closely involved in the CBD reporting process since 2009. Welcome, Tim.
Thank you very much. It's wonderful to be here. and to be speaking in these fantastic surroundings. What a privilege to be speaking in this great historical building. I'm going to really follow on very directly from Andy's presentation. I've been asked to give a little bit of, not a response, but some reflections about the great vision that you've just heard from Andy, and to think about how that fits in, builds upon, doesn't reinvent, if you like, some aspects of what's already there in the landscape. And of course, our particular interest is with regard to GBIF. And I think what I'm going to try to do is just to summarize where we would see the synergies and the areas of collaboration, and the way that each of these processes and networks can support each other, and the way in which that can happen at different scales. And I think the fact that we're here at this very exciting moment of having a new BON, as Andy has outlined, and to think about how does that activity and that effort fit in to the way that GBIF operates at the national level, at the global level, regional and thematic collaborations. So this slide is nothing as pretty as what you've just seen from Andy, but it's a rough, very simplified way, I think, of helping to illustrate where we see the combination and the interplay between these two acronyms, GeoBON and GBIF, in a way that hopefully starts to build a more complete whole of interacting and connecting and collaborating networks. So I mean, very roughly, if you think from the left, you're talking about data generation, in the middle you're talking about data processing, and then feeding into, I mean, I've described there the EBVs and the indicators, but of course also the additional ambition that Andy has outlined of the usefulness and the way in which this information is going to support policy, and also then the way it feeds back to help in the generation of more data and more knowledge. So just thinking about that, and where I've put the logos here of GBIF and GeoBON, replace those at in the national context for FinBIF and FEO, and indeed Europa BON and what's happening at the European level with GBIF nodes. So I think, I mean, in a way, maybe it's best to start in the middle, because clearly what GeoBON is able to contribute and to really inject into this whole system is a way of establishing what needs to be measured through the concept of essential biodiversity variables. That then can help to design and inform, and this is where we flow back to that data mobilization level, what investments need to go into bringing all of that raw data together. And that's where I think you get this complementarity, where in GBIF, over the 20 plus years that we've been in existence, through our nodes, through our growing network of data publishers, there's been this tremendous mobilization, digitization of collections, the bringing together of masses of data, and now increasingly through other technologies, through eDNA, through camera traps, through citizen science, bringing together that data in a way that makes it useful and for integration, but in a relatively opportunistic way. Starting out with the sort of low-hanging fruit of the data that's available. Yes, there are certainly priorities you can build into what data is going to be mobilized, but essentially it's bringing everything in you can, filling gaps, but not so much directed at a particular endpoint. It all goes into GBIF, it goes into our systems, and we know it's used a lot in scientific research. Now we're up to something like 4 to 5 peer-reviewed papers published per day that are making use of GBIF data. But we're still, in a sense, putting everything out there, supporting the use, but not mobilizing the data initially in a way that's directed towards that end use. And I think that's where the loop back from EBVs into that data generation and the priorities from GeoBON can really support and complement the activity and the approach that GBIF has taken to date. Where I think then GBIF can and I think will remain for many types of data an infrastructure that's going to be useful for this, and I would say essential for the vision of bringing together a global observatory, is the technologies and the data pipelines and streams, the integration using common standards, built up and constantly evolving in the GBIF community and our associated network and the Biodiversity Information Standards community that can support then the integration and the bringing together of not all data types, sure, that are going to go into this observing system, but a reasonable proportion and probably a growing proportion of data types that can then go into a pipeline to make that available in an efficient and effective way so that it could then be extracted for those further uses in terms of addressing policy needs, developing indicators, and supporting policy. So very broadly, I hope that sort of helps to start off that picture of where the collaboration needs to be. And I think it is absolutely essential that that is applied at the national level so that we don't replicate and duplicate some of the work that's already going on. And I'll go back to what I said just now because I think it's important to emphasize. We're not saying that GBIF is the appropriate place to be processing all of the data that's required for this observing system, but a reasonable amount of it. So just summarizing, I think, looking at it in practical terms, if we're looking at a growing network of national bonds, as Andy has outlined, what are some of the key synergies and interactions that we can see between the existing mandates and structures of the GBIF nodes that have been built up and the bonds as they emerge? And I've just summarized some thoughts and ideas here. Really, this isn't a definitive list, but I hope it at least sparks off some of the discussion. So I think, what is it within GBIF nodes that will be useful for these systems? Well, over the years, and of course there are variable levels of development and resourcing behind nodes to support this. But on the whole, it's been the job of the GBIF node managers to be across the evolving data standards, to be able to apply the commonly agreed standards for sharing that raw biodiversity data, and then the tools to be able to publish, share, and integrate those into fair data systems. The other sort of benefit that sometimes I think GBIF can bring to the table is that because we are an intergovernmental collaboration, albeit on the basis of a voluntary MOU, it means that by the time a national node is set up in GBIF, there is some mandate that comes from a national government agency or ministry, and that can obviously often be a very important basis for giving some sustainability and mandate for the national activity. Then those nodes will also have brought together a network of institutions publishing data and have connections with the global community through being part of the GBIF collaboration. On the other side, I think the national networks that are going to be set up under bonds will have, as I mentioned already, that ability to identify the priority data to mobilize and therefore bring more purpose, if you like, to the priorities and the data sharing from the nodes, strengthen the links to policy needs, and move from that from opportunistic to more purposeful data mobilization. And then also through the bringing together of the communities that go into an observing system, to bring some of those monitoring networks that often, sometimes in the case of GBIF nodes, are not well connected, to the node institution that quite often, typically, will come from, for example, in this case, the natural history collections community. I know I've got to hurry up, so I'll just go through just a couple of additional thoughts. We've been promoting collaboration with not just the national bonds as they emerge, but also with some of those thematic networks. And there was a very fruitful collaboration that we had a couple of years ago with the Soil Biodiversity Observation Network that you can see on the left there, built their own framework of essential biodiversity variables with regard to soil biodiversity. By collaborating with that network, we put a little bit of funding into seed grants to holders of soil biodiversity data that with just a little nudge were prepared to format that and to serve it into the GBIF system. And just one outcome of that I'll point to on the right, you won't be able to see the detail there, but as part of that small grant call, there was a global data set of soil organisms published actually from a group in the University of Tartu, just across in Estonia, which resulted in, and you can see the coverage there of where the samples, it was eDNA sampling of mainly fungal organisms within soil, and that was over 7 million records, which with that collaboration with the expert group brought that additional data so that it's fully available within GBIF. I'm just going to finish off briefly by referring to some advances in the way that GBIF is able to enrich and diversify the data model with which data is shared through GBIF in ways that I'm confident will make GBIF much more useful and relevant to monitoring communities. And I can announce actually that just as of yesterday, there's a new extension, 55 new terms known as the Humboldt extension, which deal in much richer ways with describing the events from which monitoring, biodiversity monitoring is extracted, has just been put to onto as an available extension to our integrated publishing toolkit, the IPT. At the moment, it's really in a testing mode because we won't yet index and process those additional fields. But over the coming months, we will see some of the fruits of that enriching of the data standard to be able to accommodate much more of the richness of monitoring data, which I think, again, is a way of bringing these communities together. And just one more quick advert for a project that GBIF is involved in through the EU Horizon 2020 program, which is working at improving the delivery of data from the GBIF infrastructure in formats, in this case as data occupancy cubes, that make that integration of data much more useful for the purposes of observing systems. And that's where I'll finish. Thank you.
Are you okay?
Yeah, I'm fine.
Yeah. I was waiting for that to happen. Oh, it's if you don't like the presentations, there's always the trapdoor that we can pull. Thank you, Tim. Now, unfortunately, our next speaker, Camino Liquete from the European Biodiversity Observation Coordination Center, could not make it today. However, she has sent us her presentation, and our own Petteri Vihervaara has promised to introduce EPOC on her behalf. I'm going to say just a quick word about Camino because, as many of you know, she works at the Secretariat at the European Commission Knowledge Center for Biodiversity in Italy. And she's a marine scientist and has a PhD in earth science and has worked several years in EU policymaking. And her presentation today will be presented by FIO's responsible director, Petteri Vihervaara.
Okay. Good morning, ladies and gentlemen. Nice to see you from this perspective, and welcome for this event also from my side. It's a really pleasure to be able to see all of you here and be having a nice day, remarkable day of the big project of the FEO, but I will say a little bit more of the FEO in my own presentation later. But I try to go through these slides by Camino in a nutshell, because that's quite relevant for current European biodiversity monitoring collaboration and a community. So there has been a project called Europabon. We have colleagues here from Europabon project consortium, and then we have a parallel network, European Biodiversity Partnership, Biodiversity Plus, who members are also somewhere there in the audience, some countries represented as well. Europabon and Biodiversity Plus have had a very close collaboration together with GBIF and EEA during the last few years to try to figure out that what kind of European structure there should be for coordinate, bring together biodiversity observations. And that's about it. The acronym has been changing through the process several times. We started with the BMCC, then it moved to IBOC with 1 C, but now it's IBOC with 2 Cs. So let's see if it remains or if it's still gonna change. So this picture shows one of the major challenges, as we heard from the previous presentations by our keynotes. There's a lot of data, but it's varying in the spatial and the temporal scales. Data integration is a challenge. Also there's quite a lot of fragmentation. If you look at these European maps, there's a quite big different color differences which show that there's a conservation status changes is changing across the borders, and for example, even neighbor countries which might have a quite similar natural conditions might have a different categories in this classification based on the available data and interpretation of the data for different data sets. So harmonization is really one of the main challenges. Then of course data access, sustainable finance of monitoring systems and full coverage are the key challenges as well. And European colleagues were asking from the stakeholders that what are the major needs of your work, and the harmonized biodiversity indicators and the guidance for harmonized biodiversity measurements were the highest in this ranking. Okay, so the next slide is showing about a bit more also of this, illustrating the gap analysis of different biodiversity monitoring programs. So there are different colors. Green is terrestrial, yellow is freshwater, blue is marine. And basically, the lighter the color is, the more gaps there are in the data. And the classification here on the left side follows these EBV classes by what we heard from Andy's presentation already. So there's genetic composition, which is mainly missing in most of the cases. Species populations are maybe the best covered in many monitoring schemes. Still, there are some taxa which don't have a good monitoring schemes. Species traits is quite new concept, but very important for the ecosystem functioning, but there's very rarely some kind of monitoring going on with traits so far. And community composition is then, of course, an important assemblage of the species, which should be measured as an entity because it tells much more about the interlinkages between species and taxa as well. And then on the bottom, ecosystem structure, ecosystem function are also mentioned, but maybe they were not so much in the focus of the Europabon project so far. The solution, what is suggested by these networks, is that we really need some kind of better coordination for Europe, coordination, integration, enhanced data collection, and that's also as a vision of this e-book for the future, that in the future, hopefully there will be central hub which collects information together, coordinates monitoring efforts across the networks and the scales, and also engage the different expertises of the modeling technologies to come together to develop solutions how the monitoring could be done in a better way. And of course, it's important to provide financial resources and the capacity building also through this kind of center in the future. So hopefully in the future, this EPOC will support coordination between member states and organizations, and also assist them to enhance and align existing monitoring schemes, develop novel techniques for monitoring as well. And also it's highlighted that this kind of center needs to integrate the results of the monitoring for meaningful indicators and also support policy processes, decision making meaningful analysis on a different scales. The vision has been, of course, very much top-down for the European Commission, but the biodiversity network has then bring for this discussion more these member state perspectives and local level challenges, which should be part of the entity also. In the stakeholder events, the project was asking what are the priority functions should be the priority functions of such European Coordination Center: coordination, data collection, mobilization, integration, sharing, and analysis and reporting to support stakeholders where the main functions detected so far. And then in these columns, the priority ones are on the middle, and then on the right side, those which were ranked for the second class, but anyway, still important for the long run. And also, it was very important message that every member state should have a national biodiversity monitoring hub which mirrors these tasks and have a similar kind of functions, serving national stakeholders and national purposes, national networks, but in a good combination and collaboration with this European Coordination Center. Then there's a terms of reference report coming out, if not published yet. The final stakeholder event of Europol project is going to be 27-28 May in Brussels, where this is then advertised for wider public. But this is the current suggestion, how this EBOC is suggested to be established. So there should be a centralized secretariat somewhere, perhaps some European institute. EEA has been suggested as one possible host institute for having this kind of secretariat role, but I don't know what is, maybe we will hear in the next talk about the EEA's view for that. Then there are EU institutions and agencies, international regional data infrastructures, transnational NGOs and platforms for coordinated monitoring. But very important part of this governance structure are the national biodiversity monitoring hubs. And the General Assembly should be then the decision-making body where national hubs are also represented, as well as EU and other key institutes. And then the Secretariat will have a more tactical, collaborative roles, and of course all the networks who are making the observations should then be involved through the operational measurements. Next steps. So the project ends. It was like a designing of the system, listening all the stakeholders carefully. But now there's already a next step coming. So European Parliament has announced 5 million euro funding for 2 years to pilot this kind of EBOC for the next level. So the work continues, and there will be open tender for consortium for that. And by the end of the year, that's going to be then hopefully decided, and the work goes on 25-26. And at the same time, of course, this Biodiversity Plus is continuing until 28. So there will be good collaboration on this European level continuing, where national networks hopefully can join forces. Thank you very much on behalf of Camino.
We'll continue a little bit more on these European perspectives, as our next speaker is Biodiversity Coordinator Janika Bori from the European Environment Agency. Janika works with cross-cutting issues of supporting to bend that curve on biodiversity loss, and serves on the advisory board of the Horizon Project's Biodiversity Plus and observation of economic changes for action. She has also worked, for example, as a research diver, which is quite the CV thing. Please welcome Janika.
Thank you. I think it's about 1 hour since the last cup of coffee, so I hope you're still all awake. You can see that the budget cuts announced this morning are already affecting the screen, so bear with us. So I knew that following up on Camino's presentation, you would have all the information you need. So I'm going to take a little bit of a different route to where we want to get. Yesterday, I attended the Biodiversa Plus meeting held in Helsinki. And we had some very interesting discussions there, some very good exchanges on what exactly is needed. Now, you've been fed for this last hour, you've had all the details. So here is what I start with. I have a dream, a humble quote. A dream that one day we will have a single measurement to describe biodiversity to decision makers. So spinning off what Leif said about the climate colleagues, about how work has progressed on the climate change science, they actually have a way of describing and measuring climate change with numbers. And this gives them the benefit that they can easily communicate to the decision makers that this human activity is quite bad if we want to stop climate change. And that one is even worse. And that's absolutely the no-go zone, don't go there. We lack that when we try to describe biodiversity loss. And the work on establishing an EBOC, as we're now calling it, is the foundation to get to this point. So I had a look around. How can we describe this? Do we have already something to start with on describing biodiversity loss? The word in itself is a bit challenging, in fact. Biodiversity, in Finnish monimuotoisuus and in Swedish mångfald, those both languages include the word many. So already it's a little bit off-putting for decision makers to hear that this is something big, this is something many. It screams of complexity, and it's our job in this room to decomplexify it for them. There is the Living Planet Index. This is a very nice time series, goes back all to the 1970s, produced by WWF and the Zoological Society of London. That's pretty easy to communicate, but the caveat being, it shows you trends in vertebrate populations. Now, do we want to say that biodiversity is only vertebrates? I don't think so. I wouldn't be doing a fair game if I wouldn't look at our own products. So at the European Environment Agency, these are our two main products in the terms of biodiversity: the state and outlook of the European environment and the state of nature in the EU. The state and outlook, SOER, among friends, is of course much broader than that. The previous one came out in 2020. In fact, we rushed it and it came out already in 2019, before my time at the agency, and greatly affected the Green Deal. Now, colleagues back home are already working hard on this, and the next one will come out next year. The state of nature, this is the report that gathers all the reporting from the Habitats and Birds directives. So that one comes out every 6 years. Previous one also in 2020, like the SOER. Next one comes out in 2026. This is how we communicate our main results from the state and outlook of Europe's environment in 2020. It's not a single message. It's not a single measurement. It's good. Knowing what goes into this report is quite good. We have the nice color schemes that clearly communicates to you good, medium, bad. But if we want to know about biodiversity and biodiversity loss, you did look at natural capital, the first chapter. And people there in the back, you won't even be able to see the nitty-gritty text. But I'll help you. We go into common species, ecosystem condition and services, water ecosystems and wetlands, hydromorphological, that's where you lose the decision makers. So, an okay piece, but not what we're looking for. State of nature, this is what it looks like. We're doing a bit better on this picture, I think. But what are we actually looking on whether there is a good status or improving trend for these species? We're looking at the bird species, the non-bird species, and the habitats that are listed in the Birds and Habitats Directive. Is that all of our biodiversity? No, it's not. So, today you've heard a lot about data, collecting data, comparing data, but what is data? Data is the information we have here on the left. And only when you start seeing some details in this data does it become information. When you start connecting the dots, you have knowledge. And when you start seeing patterns and seeing things that somehow belong to each other, that's when you have insights. Insight is already a good way. And I think we have insights already. But to get to wisdom and to impact, to be able to communicate this with impact, to actually make a change, because we have people to convince. EU elections is only a month away, a bit more. You have to go through this whole process. And today we're talking about EBOC and about the first pictures there, the first 2-3 pictures. Remember that it does matter who has the insight and who has the wisdom, who uses the wisdom. Because otherwise, it might look like this. So if you have the insight and you go the wrong way, the wrong people, the non-experts using the wisdom, you might start connecting the dots in a whole different way and come up with flying unicorns. Courtesies to my colleagues for this pretty slide. That's not where we want to go. Hence, what we need from the EBOC is to have, and this slide is a repetition of what Camino's slides contained. We need to have the structure, we need to have a clear mandate, and we need to have active parties working on this. We need to work through the whole scale of data and interpretation, coming to knowledge, and to communicating it very clearly. Because if we're stuck on biodiversity is complex, then we're never going to make a change and never going to curb the loss, the biodiversity loss. For the EA, we are one of the possibilities to host this. From our side, we're still very willing to host the EBOC. Right now, it's stuck with this 5 million that Petteri mentioned on whether institutionally we can be the recipient of this money. So I think it's Brussels who needs to decide on where this money goes and who will start hosting this. And that's all for my time. Thank you.
Thank you for all of those interesting perspectives, Janika. I'm sure that by now you all have many questions in mind to our keynote speakers, and we will have a little while for Q&A in a little bit, so keep those questions in mind. But first, introduction to the reason that why we are here today, so introduction to the Finnish Ecosystem Observatory. And to do that, welcome back on stage, Research Professor and Director of FEO, Petteri Vihervaara.
Okay, now we go to the business of the day. So this is just like a warmer for the afternoon. So hopefully you're going to have a deep dive for all the details what has been done during the 4 years. It has been really a major project. Thanks for the Ministry of Environment for significant funding for this project. Thanks for all the Syke collaborators. We have got altogether over 80 individuals working for the project during these 4 years. Some of the names are here from the report, but there are also many others. So thanks for everyone, for everyone's contribution. It's really a joint effort. And also with some other institutions, not only Syke, but we have also had a good collaboration with other colleagues as well. So I try to explain a little bit of the framework, and then we will go deep into details later today. So this Finnish Ecosystem Observatory planning started already from the headache of the 2080, 2090, that all the data in our institute was scattered across the different people's computers and laptops and not accessible, not findable, not available, and not reusable. But huge effort, high quality data, but it was really difficult to get that data for research projects or assessments or anywhere. So we thought that we need to improve this kind of system somehow, and I got very impressed of the work with the Geobon and colleagues there. First harmonize different dimensions of biodiversity through this EBV framework, but then also to think about the entity, how the data should be shared. So with colleagues, we were inventing this proposal that we should have a strategic mind. We need to cover not only biodiversity, but also climate change-related measurements for ecosystem processes like carbon, nutrient cycling under the same umbrella. 3 key items where the work was allocated was covering management of data interoperability, then modernizing and bringing new methods for biodiversity monitoring, together with the traditional methods, which are, of course, the backbone and the very important part of the monitoring long-term work, and then integration and demonstrating the importance of the knowledge for decision-making at various purposes. So the basic idea was that if you have a high-quality data, you can use it for many different purposes across the society at different scales, from municipalities to the private sector for reporting of the experts to the different directives, research projects, or you name it, different international agreements. Close collaboration has been done with the Europapon project, as said, and also Biodiversa Geopon colleagues as well. This is another illustration which many of you have seen before in some circumstances, but on the upper side you can see the 100 years of the Finnish traditional biodiversity monitoring schemes with an increasing trend towards the 90s. Different monitoring schemes were popping up every here and there with the enthusiast citizen scientists or some researchers, but there was not really a national coordination of that. What we are going to study, where, which kind of methods, how to store the data, and so on. And because of all the economic challenges, it has been really difficult to keep them all up and running and find always some one more year funding from Ministry of Environment to prolong these schemes. So we hope that maybe through this kind of harmonized overview we could bring some solutions which will support all the different schemes and maybe give a little bit help for their burden to go on to the field and really make the important observations. And another important element is then increasing quality of analysis-ready datasets from the remote sensing products, which could be really having a wide-scale wall-to-wall information, which supports also these traditional in situ-based observations through the models to understand better how the nature is changing. We got a rapid start for the project already first year when we just had a big promises and not really results. Science made an article of the promise of the satellite monitoring to preserve biodiversity. Elizabeth Pennis was getting this kind of interview of several colleagues from the Geopon community and really trying to bring in some of the ideas that how this could be maybe improve the monitoring schemes. And in that article there was also reference to the FEO project, which will announce to be test the feasibility of determining boundaries of wetlands, forest and other ecosystems in Finland. So afternoon you hopefully will have a little bit additional taste for what we have been doing for this premise. And EBVs are important classification category also recognized in this paper, and that has been also leading our work, even though we haven't been highlighting too much the term, but it has been like a concept behind the work and how the work is allocated through different work packages and different items. This is another graph showing the data from the left side from different data sources flowing through system where the data is available, to the right side for different decision makers purposes, applications across the society. So we have been working with all these different parts. Quite a lot of work happens there on the left side, so the data should be really improved and created and made in such a format that it's available through the APIs for this kind of centralized platform or service where you can find different data providers' products, and also demands for this service where that we should have both raw data for researchers or anyone who really would like to see it as raw as possible for their own purposes, but then at the same time it's very important that we make some kind of data products like indicators. Luonnontila automated indicator portal or web service was mentioned already, and there will be presentation afternoon about that work. So these both are providing important components of this future service. And then the different use cases, of course the demonstration. On the bottom of this picture you can see data, work packages, in situ observations, earth observations, modeling. In the middle is this engine, this interoperable information system that has been discussed and developed as a first prototype, but that's the work that continues after the project. And then the demonstration pilots, these cases in the work package 2, showing 5 cases which have been piloted to demonstrate the data workflows. And then first work package, maybe the most important one, that what are the networks, the stakeholders, what kind of demands there are from the society, what kind of data is needed. Because that's, of course, always the selling point also for financial decision makers if you would like to get this kind of excuse to make good monitoring system happen. I go very quickly through these work packages, but there will be more afternoon about this. So about the work package 1, that was use of environmental information. The main outcomes show that the demand for information is really rapidly growing, and the users of the environmental information are becoming more and more diverse. There's really a lot of need across the society. And also there must be really different kind of expertise that ensures the success of knowledge for the use. Work package 2 covered 5 different case studies. First one was demonstrating the use of monitoring data for these indicators, Luonnontila web service. Second case study was showing the use of available habitat data for habitat directive assessment, process and threatened habitats. Then there was a case study of carbon neutral land use habitat management. And then very important also for the future collaboration, producing data on nature needed by municipalities and regions. These local level decision makers are really key to provide data, but also use data, and they are maybe the first ones who make decisions if the nature is getting better or worse condition for the future. And then quite significant for the state economy and the sustainability in general is the case study of the ecosystem accounting in collaboration with Statistics Finland. Then to the data work packages, in situ work package that covered making the most of field inventory data, 5 different elements. First, quite a lot of attention was paid for molecular monitoring method assessment development, and we made a roadmap for the Finland how eDNA and other molecular monitoring methods should be implemented in Finland. Then there was a complete review of species monitoring schemes for Finland. Almost 90 different species monitoring schemes are run in Finland, and that was really a big state-of-the-art assessment that was done for those, and also recommendations, possibilities for synergies. Then there was quite a lot of old habitat type inventories done, but that information was only available in a paper format, so we paid quite a lot of effort to try to get these old maps digitized, and that's also quite important information when the restoration impact is estimated in the future, and if you are looking for places where the restoration is maybe the most promising one. Then there was quite a lot of work going on with this carbon concentrations and carbon balances and how this could be measured and modeled. And then collaboration with these intensive monitoring stations, Elter network collaboration, how the instrumentation and observations could be also better serving biodiversity knowledge production. Work package 4 was about the remote sensing to use. Main outcomes of that were that there was quite a lot of discussions of the user needs assessment, what is really needed. So remote sensing can provide a lot of different kind of data, but what is the most useful for the environmental monitoring community or biodiversity researchers. So that was analyzed and assessed. Then there were workflow descriptions to show how data is processed and analyzed into usable information. Over 30 different remote sensing data products were published to support biodiversity monitoring. And then there were also some more research-oriented applications demonstrating the possibilities of the remote sensing, like quantifying ecosystem condition of Aapamajos, presentation afternoon, and use of artificial intelligence for detecting rare nature phenomena like uncommon tree species or dead wood in boreal forests, also presented in the afternoon. Biodiversity and ecosystem models to cultivate information was a work package 5. Here we made a quite big strategic analysis also that what kind of landscape we have. There are plenty of different kind of models, all having a different pros and cons and the challenges and uncertainties depending the data and the use, and also how the models are. Is 3 or 1? 1, okay. 5, then I can relax, thanks. So that how how the models are interacting and what kind of landscape there could be to bring models work together in a proper way to provide meaningful information. There were especially species distribution model concept and a joint species distribution model concept tried to apply for understanding biodiversity values of boreal forests. Then we paid attention how to feed in drone-based observations for improved species distribution modeling, for example, lichen communities in one case study. Then there were models for current greenhouse gas balance calculations. There were also scenario modeling and work done for the process-based models to understand better the alternatives for forest management strategies and measures through the PREPAS modeling system to understand forest growth and the carbon balance. And then spatial prioritization, zonation, and applications of zonation, how these other models could maybe feed in then data for zonation in the future. And some special issues also which are reporting these exercises. Then we come to this really IT part of the work and the hardcore, how to make the species and habitat ecosystem observations available and findable, harvestable. So that was the work package that was really thinking about that what is the smartest way to handle big data and provide good search engines for different data sets. One of the key exercises was done with national habitat data, because that's one of our duties, what we need to do when we report for the European Commission about the Habitat Directive. And that's quite complicated process and exercise already in Finland. So there are over several tens of data providers whose data should be compiled together through the different databases to make the big picture that what's going on with these habitats in Finland. And this kind of habitat architecture hopefully helps in the future to understand the process, that with whom there's interaction and what are the APIs where the data could be maybe findable. Then quite a lot of emphasis was done for digitization and publication of these old nature datasets, which were also part of this work package 3 a bit. And then there were methods developed to document data processing and automate data retrieval, improving the reusability and accessibility. And then the surface or the front page of all that work done there behind is now hopefully available through this new web service, Luontotieto, Finnish Nature Information Hub, that was created. And there will be a demonstration in the afternoon about that. And then hopefully the even more long-lasting impact came through the extending of the collaboration to other networks. So during the last year of the FAIR project, we spent quite a lot of effort to try to bring also other institutes and organizations together. Altogether, we collected 17 organizations together. We call it a network like a lukki, long leg spider in Finnish, which has all kind of networks to better bring together data providers, data users, and that's the hopefully continuing to at least the next decade the work. So this is the highlight of this Luontotieto Nature Information Hub. There are 3 elements. The one on the left side is about the data search. There will be metadata available from this service with the different categorization things. Then we have a middle part, monitoring and methods, which describes the overview of different Finnish monitoring schemes and the methods which can be used, and also explains a little bit of the uncertainties related to methods and the sampling. And then on the right side, there are the services to different nature products like this processed indicator information, for example, and other services, which gives a more like overview and a more applicable information of the change and knowledge in the nature. Then a picture on the right side shows a graphical illustration from the Biodiversity Network, how we saw this future collaboration with EBOC and national hubs. There should be really same functions recognized on national and European level. And we think that very much that what we have been establishing now in Finland and with what that will continue hopefully after the project funding ends, that could really bring Finnish national hub available for this kind of international collaboration. With these 17 organizations and their members, we established a paper that is actually available there in Finnish. I think it was translated also maybe to some other languages. But anyway, it illustrates this plan for the next decade to improve Finnish biodiversity monitoring and biodiversity information collaboration under the 4 different categories: use of data, monitoring coordination, new method applications, and data interoperability development. And then bringing that also to the science community, we think that the high-quality observations are really the basis of the high-quality science. So it's important that we have this monitoring data that is shared for anyone who needs that for their purposes. We think that categorizing observations through the ecosystem-related EBVs, or on the right side to these more in situ-based species-related EBVs, they should be balanced, and both are important. You can't just go for one. You need them all together. And also it's important that you try to improve the spatial and time-temporal resolution, but also develop these standards for novel methods. Because, for example, EDN applications are in a situation that there are really plenty of possibilities, and if there's no really coordination and guidance, it might be that we have so diverse data that it's not useful for any kind of synthesis or analysis if it's not decided together and discussed what's the best way to do it. Then there are interesting topics in biodiversity like traits and community responses for different drivers and ecosystem functioning, and also to integrate for the larger society and human impact for the biodiversity. So this detection attribution of drivers' pressures is important. And we think that those are the possibilities what this kind of national data infrastructures could really support and boost also for the academic research. So with these words, I think I end here, and thank your attention, and my collaborators and everyone who have been involved in the project, and more acknowledgement will follow in the evening party in Korjaamo, where we can relax a bit. So thanks.
Thank you. All right, as I promised, we have a few minutes for questions or comments now. Do we have any questions from the audience? All right, someone will bring the mic to you so that the people on the stream will also hear. Yeah.
Thank you very much for very inspiring talks. I think Andrew's concept of biodiversity forecasting very well put what we're after, that we would have some kind of clue of the responses of biodiversity to human actions. So my question is to all speakers, how are the human actions and the human-induced pressures accounted for in these observation and monitoring systems, and how should they be?
Who feels like they want to start? Andy? Yeah, your name was mentioned. Please come on the stage. Yeah, thank you.
Thank you. Fantastic question. So it was implicit that we were talking about how humans modify the landscape, coastlines, the oceans. And it's really quite important that if we're going to get to this understanding that allows us to make a forecast, we have to understand the causes of change. We have to have a very clear understanding of what leads to a certain outcome at different timescales. So that means we have to pair the monitoring of nature to the monitoring of the underlying human drivers. And that's difficult because that requires collaboration among other networks. You know, there are other monitoring networks for pollution, for climate, for the other types of drivers, land use change. And so that requires our community reaching out to other communities. And there are other concepts out there like the Global Ecosystem Observation System of GEO, which is about connecting observation systems. So to wrap up quickly, if we're going to get to forecasting, we need to work with other networks to get to that point where our models can couple to these underlying drivers and causes of change.
Thanks. Just to add to this excellent reply, that's a very good point to make, because if we only would monitor the observations of nature but not monitor the pressures, then we're only on the very last end of this dialogue, so to speak. So in order to see when a reduced, or let's say the other way, in order to see biodiversity start improving, the first signs will be that we actually manage to reduce the pressures. So you're spot on there with this question. And even though maybe it wasn't mentioned in those words, that's a big part of this process.
And a few more words as a reply as well. You must realize that this, the whole theme of data management and collaboration and gathering different data sources together, it's by no means restricted to biodiversity. It's a discussion that goes on in all fields. It's about demographic data, health-related data, economic data, combining all these and so on. So this is a process that will certainly go on, and it's kind of like ripples on the water, that it expands and expands, and we should never allow us to kind of stop or restrict our thinking into as soon as we gather all biodiversity data, then all is fine. We are now planning in Syke to combine some economic data and modeling to already now to biodiversity data. We have this environmentally extended input-output model for material flows in the economic system. So we are trying to be, forerunners in that area as well. And it's I feel it's really interesting and certainly answers the needs of society.
Thank you. Fantastic question. Here.
Hello, Juha Seppälä, European Investment Bank Environmental Policy Unit. And Leif already touched upon this, but what's the linkage potentially between what the private sector might be looking for in terms of what are their impacts on biodiversity or ways in which they could actually, improve their biodiversity performance, so to speak? Is there a linkage here that could be potentially explored? Thanks.
Haluatko Petteri tulla?
Okay, so yeah, that's a very good question and really important, because that's also where you can get the best impact for really conservation and improve the biodiversity, if you can make a meaningful biodiversity data available that affects for sustainability assessments of the private sector. So we have been, of course, thinking that from a really wide point of view through this FAIR project. So really starting from the communities, those land use planners there, coming to the collaboration with the Mappa collaboration, which develops products for the schools, for the kids, for the teachers, how the data could serve them purposes, and then also different kind of other collaborations as well. But this financial collaboration or finance sector, I think that's maybe the most important, because that's really in the beginning of the source of all the economic activities and the data. And if they are dealing with the different sectors, that they want to have a particular, for example, biodiversity footprint assessment for the investments where they give money. So I think that's the way how you really can bring this biodiversity data to the source of the economic benefits. And then if they are taking care of all the different sectors, I think that might have a really big impact for the whole society, so that the high quality biodiversity data also serves for the private sector needs. There has been actually some collaboration, and I think Jabon has been discussing with a particular networks task force for financial disclosures on nature, that how, for example, EBV approach could be harmonized way to guide and steer development of this kind of financial sustainability indexes. And this could be maybe a way forward what we try to seek out, if, for example, it could be demonstrated through the biodiversity network. But of course, it needs to be piloted on a small scale first and think about small steps how to reach this bigger picture. So.
Yes, maybe I could just complement that by saying that as well as the private sector clearly being a very important critical user of the information and the data that flows through this system, they are also a very important provider and source of data, which to date has not been tapped enough, but increasingly now is starting to be. For example, all of the data that's brought together for environmental impact assessments should be made public and should be fair and open and contributing into the global knowledge base. That is really starting to happen in a number of countries through the influence of GBIF nodes, other networks, but also through financial institutions and development banks who recognize that it really should be part of the conditions, in many cases, of finance and loans, that the data generated as part of that licensing process should be made public. So that's something which I think can hopefully drive and create more virtuous circles here.
Thank you. I think we have time for one more question. Oh, okay. You want to come here and ask it?
Yes, actually, I have a comment or question or a challenge to Jannika. I will try and, or how should I formulate it? You had a nice dream, but I'm afraid it will turn into a nightmare if you stick to it. A couple of months ago, we had this seminar in Finland on for the financial sector and their work relating to biodiversity. And I was very happy to see there that several speakers repeated that although we need numbers to be able to make financial decisions, we have realized that we shouldn't ask for a single number. So if we really strive for that dream of yours, I think we might end up with a nightmare, because then we will just, go in circles, spending time on trying to find the one and only number that everyone agrees on. So yeah, it's a nice dream, but maybe you should relax it a little bit.
Maybe that was actually something I wanted to comment. As I said in my presentation, there are complex issues, and as my role at the ministry, I think it's also important to tell that there is complexity to the decision makers. I thought also that would be not a good message from me, for example, to the minister, to say that we should aim for the one number. But to say that it is a complex issue. But of course, try to make it as simple as possible, but still include the complexity.
All right, challenge accepted. This is, of course, more of an inspirational thing. I forgot we're in Finland, everything is very verbal. So yes, I admit, one number, one single measure will not work because of its biodiversity. But we do need to go a little bit towards that. I mean, complexity is good that it can be communicated now. It's really good that we're getting there. But what we are seeing in Europe is that saying that nature needs to be preserved for its intrinsic value, it only goes so far. I mean, it's a select audience, most of us in this room, who agree with that. Just look at the hurdles that the nature restoration law, it still hasn't passed. That's the nightmare. So, we do need to improve it a little bit. Maybe we have a compilation of numbers, something that describes it a little bit better. But yeah, of course, yeah, a dashboard, yeah, of course. So let's not make it into a nightmare. Thanks for the feedback.
All right. Now, so maybe this Q&A session turned into a bit of a debate, but that was really interesting. Thank you for those comments. And I'm sure that this conversation will continue both over lunch and over beer later at the after party. But first, before I give you the freedom to go to lunch and break for lunch, we have something a little bit special prepared for you. An art and science collaboration video created by Joona and Tapani Toivainen titled Nature Talks to Us. I'm just going to give you short introductions to both Tapani and Joona. Tapani is a visual artist, jazz musician and software engineer, and holds a master's degree in bioelectronics. And he has worked with mixed medium contemporary art, including visual and direct manipulation of matters and AI. And the other creator of this piece you're about to experience is Joona Toivainen. He's an award-winning Finnish jazz pianist, composer, and music educator based in Sweden. And they have prepared a little video to introduce to you the actual art piece, and the piece will play after. Thank you.
Hello, this is Joona Toivainen calling from Gothenburg, Sweden. I am a composer and a jazz piano player.
Greetings, this is Tapani Toivonen, joining from Copenhagen. I work as a software engineer, visual artist, and jazz musician.
And some of you might have guessed that we are also brothers. Besides working with our own projects, we also play in a jazz trio together. Tapani is also a fantastic double bass player. And for some years ago, we were having a concert at Tampere Jazz Happening, a big festival in Finland. And after the gig, this gentleman, Petteri Vihervaara, came to talk to us. He's one of the guys at the Finnish Environment Institute. And he thanked us for the show, and he had seen our previous work where we combined music and video work, and he initiated this idea of combining our work with their research data, basically. And we booked a meeting, and some months later we met at the beautiful Cafe Engel, right next to the big Helsinki Cathedral, together with myself, Tapani, Petteri, and also Aapo Kahilainen from the same institute. And we started gathering usable data and video footage, and I started sketching the musical ideas, and the ball for this video was finally rolling.
And I was very excited by Petteri's and Aapo's ideas to try to tell this different story of nature using research datasets as the source material and inspiration. And environment institutes work with indicators and sensing models, and to monitor the state of nature is very important and inspiring. And the title of this video work, Nature Talks to Us, is a way of saying that not everything that nature has to say is perceived by our human senses. Nature talks in so many different ways and in different timescales. Much of the work of Environment Institute, and also the goal of this video work, is to study this unseen nature and its ever-changing ways of interacting.
And musically, I wanted to combine these two worlds of partly the acoustic instruments, field recordings, and natural resonances, and I wanted to combine that with something more digital, more programmed and processed sounds. So I wanted to have these two worlds present at the same time and let them interact with each other. And I started sketching my ideas, Tapani did his, and we had a ball game going on with throwing ideas to each other. And then gradually we started to find themes and structures that sort of were inspiring to us, and that's the way we worked, basically.
And in the visual side of the work, we use location footage from the Mars and the Tundra of Finnish Lap, and use means to represent datasets using digital simulation models, also 3D visualizations and learning algorithms, to tell this story of different side of the nature that you are perhaps more intimate with in your research. Lastly, we would like to thank Petteri Vihervaara and Aapo Kahilainen at the Finnish Environmental Institute for initiating this collaboration. And please enjoy the video and presentations of the final seminar.
Thank you very much.
With that beautiful piece, thank you everyone for this morning's session. Now, lunch will be served in the same hall that we got the coffee this morning, so Myllysali, those of you who had time to get your coffee will show you the way, it's that way. It will be served in lunch boxes if somebody wants to brave the beautiful Finnish rainy spring weather. You can have it as a picnic on the fort. All of the food should be vegan and gluten-free. If you told us about any other dietary restrictions, they will be served special for you. And we'll meet back here at 20 to 1, so just over an hour's time. Thank you. If I could ask you to start calming your conversation and please return to your seats so that we can begin. Did everyone enjoy your lunch? Yeah. Did anyone brave to go outside? Yeah, some of you are waving at me. I saw some of you with binoculars outside, which I thought was a very event thing to do, to bring your binoculars to Suomenlinna on an indoor seminar day. All right, this afternoon session, we will be focusing on the outcomes we have from the 4 years of hard work with FAIR. And everyone presenting are with the Finnish Environment Institute. And as before, we have slots allocated for questions throughout. We have more of them now, so please keep your questions in mind. And now we'll continue until about 4:30 or 4:20 today, but we break for coffee at about, in just over an hour at 3 o'clock. So, yay. First half an hour or so, we focus on on-site observations, led by FAIR Group Manager Päivi Sirkiä, who will first introduce the work. After Päivi's introduction, we'll dive deeper into case studies and work, which will be presented by Senior Coordinator Aapo Ahola, researchers Ari-Pekka Auvinen and Tiina Laamanen, and Senior Research Scientist Veera Norros. But first, Päivi.
Yes, hello everyone. Great to see you all here and on the lines as well. Yes, my name is Päivi Sirkiä. I'm from Nature Solutions Unit. And I have had the privilege to guide the work package dealing with field data and observation networks. And I'm going to continue the discussion about numbers and how we need numbers. And we need to provide numbers for the society about how nature is doing, what's the state, and what's the direction. And we need to also to be able to translate our numbers to more economic language. And without monitoring, we cannot do it. I'm not aware of any good quality biodiversity footprint index which wouldn't include good quality monitoring. So, yes, a lot of monitoring needed. And behind monitoring, there are most often field observations done either by people or machines and processed by people or machines. And even those monitoring data that is being produced by or is based on Earth observations, also those need some field data to validation. So monitoring data is really crucial. And what we have been doing in FAIR project, we have mapped the current status of monitoring networks, and we have also been developing these monitoring networks. Networks of species, habitats, and ecosystem processes. And we have been also trying to facilitate the interactions between these networks. For example, putting together species data and habitat data. Sounds simple, but yes, a lot to do. We have been working with all these terrestrial, freshwater, and marine environments. And we have also been developing novel monitoring methods. For example, environment DNA methods in different ecosystems, machine observation data collection, habitat monitoring, and using weather radar data to observe animal movements. most of this work has been done in collaboration with other institutes or networks. But what would be the conclusion then? What do we need to make the most of observation networks? If I would need to pick up one thing, I would say that we need National Biodiversity Monitoring Program, including national coordination of monitoring schemes and more collaboration and synergies. I dare to say that in FEO we have been doing really great job in finding more synergies and putting up new collaborations. But actually from now on it's getting even better because there will be this national coordination group for biodiversity information, including 17 different organizations. So yes, we have done well and it's getting even better. And with these words, I thank you for your attention and funders, of course, and all the people collaborating and those persons who have contributed so far.
Hello, good afternoon. My name is Aapo Ahola, and I will present two kind of separate works or entities done under this work package which Päivi has led. So, and the kind of the roof name for this is Habitat Monitoring for Finland, Old Data and New Approaches. But let's start with the old data. So this is work done by these people, and it's about digitizing and saving old data that is on paper reports. And these paper reports are now threatened because, for example, the storage capacities or facilities of our administration is shrinking, and they are always threatened. They should be in digital form also, of course, to be accessible by others. So these are the most important data sets that have been digitized in this project. So the first one is the inventory data for this conservation program for Herbridge forests, which was carried out in the 1980s, and all these valuable geometries of Herbridge forests have been digitized, but also quite extensive amount of additional information. And then there is this small inventory of small water bodies. So there is also these geometries digitized, but also the additional information related to them. And they are now in these open access materials of Finnish Environment Institute. A third quite extensive material is this ESCAR data, and the same thing, the geometries, but also some additional information was digitized. And then along with these habitat types that I mentioned, there is also a habitat information dataset of this white-backed woodpecker habitat polygons or inventories. And in addition to those, there is still some more local studies or kind of limited in spatial scale, but nonetheless very, very important and very valuable data sets that have been carried out in northern Meyer areas. And these are not open materials, but can be requested from Syke, these digitized data. Okay, then we move on to these new approaches. So this is there are several projects, and these LUSEC and LUSEC projects are the most important, but FEO has been supporting these. And I will just scratch, it's a quite extensive entity, this whole thing, but I will just scratch and elucidate some ideas about how to monitor ecosystems on habitat type level better in the future. And quite many experts, these, but also many others have been involved in this work. But although this is a very short presentation, I thought that there has to be some time for one motivational slide, because this is very important that we habitat type experts communicate about this. For us, this is very clear, but to explain these needs and this value for someone who is not expert on habitat types or doesn't even know what it means, it's very important to try to share this information. So why do we need this monitoring on habitat type level? Why don't we just take forests and monitor from satellite? We know where the forests are and so on. Okay, and often we have also studies that where we have kind of divided the Finnish forest into 3 or 4 most common forest habitat types. Is this not okay? Because they cover 90+% maybe of the land, of the forest land. Well, this is the typical forest. This is the typical forest land of these habitat types. But the forest ecosystem is also all these habitat types. All very different habitat types, and many, many more. There are tens of wooded habitat types. And this is very important. These more uncommon habitat types contain a major proportion of biodiversity in the forest ecosystem or other ecosystems as well. And the same applies to the functional diversity. So, oh no. Was it the time, like, okay. What to do now?
No idea, actually. We can try something. Oh,
No niin, kokeillaan.
Menettikö sä niinku ton yhteyden tohon tykkiin kokonaan?
Joo.
Mistä ne näin viuhat? No niin, okei. Uhu.
Yeah, so okay, so yeah, the habitat types is, I like to say, it's for ecosystems, a habitat type is the same as the concept of species is for living creatures. So it's very useful and meaningful unit of the beta level biodiversity. And the aim is also to recognize what we can do via remote sensing, but respect the limits of it. So we have formed an outline of the whole kind of comprehensive system for habitat type monitoring. And it consists of the National Forest Inventory, remote sensing, then some aquatic monitorings, but also we have recognized an urgent and unsurpassable need for a new field monitoring infrastructure, which we call general field monitoring of habitat types or terrestrial ecosystems. And notice this here. These field inventories produce ground data and validation for AI learning. So as much as we like to lean on the future of this remote sensing, all the experts say this is currently the bottleneck. We cannot, it is the shit in, shit out principle. We cannot develop decent remote sensing modelings and monitorings if we don't have precise, accurate ground validation data. Just to briefly still show you what it means. So in this work we have tried to understand what should be monitored, and from a wish list we have gone to a kind of prioritization, and also under which infrastructure it could be monitored. So under which of these kind of, is it remote or field-based and so on. And then something also about how, with which methods. So, but we started by identifying the essential biodiversity variables, and we have gathered this extensively for all other habitat type groups except the marine environments. So if we zoom in, for example, to the forest habitats, there we have some habitat variable groups, and we can zoom into the tree and stand related variables, including deadwood also. So here you can see kind of our prioritized essential biodiversity variables for these ecosystems, habitat types, and these variable groups. And then we can see how they kind of can be monitored under all these different systems. And we are moving, of course, from the field systems to the remote systems. So, but under the first inventory round, we must gather more information on the field. Then later on, there are some variables that can be like transformed to a remote-based system. Is it time, or do I still have 1 minute? Ah, several minutes. Okay, that's nice. Okay, but okay. Last, I will show you some kind of further spin-off testing we have done under this LYSEC project. So if you were worried about this, okay, but this new field monitoring infrastructure, what are you talking about? That how can it be organized? And so good news. We have already started it with it. We have piloted it and are piloting it further. And it's I must say it seems quite promising actually, and not too expensive either actually. I am all the time stressing that terrestrial ecosystems deserve a likewise ambitious long-term monitoring system as we have for natural resources or many other things, climate, economy, or many other things. And it's very surprising how little we actually have this kind of ecosystem level monitoring for different variables. How little we know actually what is going on in our nature, except for some species groups. So just kind of this kind of taster for this piloting. So just with a set of 27 transects, which represent 2% of Finland's land area, we have been able to estimate that with this kind of it's kind of randomized sampling system, we can gather a national probabilistic sample for circa 80, maybe more, % of uncommon habitat types. And also understand all the gaps in our current data sets, which are based on all this remote data. So here you can see, for example, the orange is data on different habitat types in our data systems, and the blue is when we went through these monitoring transects, how many habitat types we found. So, for example, you can see that for herbage forests, we had maybe 30 occurrences on these lines, these transaction monitoring lines that were randomly shot into the on the map, and we found more than 300 herbage forests. On the other hand, we can see that some lakeshore data sets were quite good. We found them plus or minus there where we were expecting them to be. Then some quite rare habitat types, for example, springs, spring complexes, or scree, kivikot in Finnish. So there were only a couple, like handful of occurrences in the dataset, but we found more than 30 of both spring complexes and screes. Yeah, but maybe my time has come, so I think this is some introduction to where we should be aiming and why it's very important to have a field monitoring system along with all this development in remote sensing. Thank you.
Yes, hello again. So the second example is about species inventories. And this is work with what we have done together with Ari-Pekka and with help of many, many colleagues from different organizations. So we have assessed the status of species monitoring schemes in Finland. So we have been doing expert interviews, more than 30 of them. We have had 2 workshops and a web survey. And with help of those, we have then summarized the current state and development needs of species monitoring schemes. So we had few criteria for what kind of monitoring schemes we included in. First of all, it needed to be active still, and it had to be at some level nationwide, and it also had to be at some level systematic, meaning that there's some kind of protocol that is repeated, at least at some intervals. And we did include terrestrial, freshwater, and marine environments. And this was actually the first time to put together all these environments when comparing monitoring schemes. So the borders are still quite high, and there are not that many people talking between these different ecosystem types. But that's because of historical reasons. But I must say that we are getting better and better in that, so there's hope. Yes, the report will be published soon, in near future. And altogether, we included 86 different monitoring schemes. So from these example photos, you can imagine that there are very different taxa, very different methods, and also different organizations behind these monitoring schemes. And in addition to the report, soon coming, we summarized some of the key information about these monitoring schemes to the new sites, luontotieto.fi. You will hear about these sites soon, more, but we are just showing shortly a couple of examples what we included there. So first of all, we included information what kind of monitoring schemes there exist in Finland and more about the different monitoring types, what we have.
And this is the list of all the monitoring schemes that we have, or they are available online at this Luontotieto site that will be introduced soon. If you know the history behind these monitoring schemes, you might share my enthusiasm that we finally have collected all of them together with the basic details of the contact details and maybe some methodology and so on. If you didn't know the history, maybe you'd be surprised that it's only now that we have a list of these monitoring schemes. Well, we did analyze the monitoring schemes a bit. This is one example. We looked at which main habitat types are included in the schemes and which species groups. Well, it's an unbalanced picture. Well, it's probably no surprise to anyone here. Well, actually, I mean, it's has heavy emphasis on terrestrial habitats, but then if you actually had a similar graph of the area of Finnish main habitat types, it would actually look a bit the same in terms of coverage. But then, of course, vertebrates are heavily represented in the monitoring schemes, and we should really do something about that in the future. Okay, future steps. We will be making 19 recommendations for action altogether. Some of them are related to, for example, what Apo was just talking about, habitat monitoring. There should be better linkages between species and habitat monitoring. A lot of the topics you'll hear after us, including new techniques and technologies. We should also make a gap analysis, referring to the previous slide. But then I think it's kind of the roof concept for this is what we actually quite logically have number 5 in our list, is to have a monitoring program with adequate resources, including some sort of a secretary and a standing committee for species monitoring. And as Päivi said, we've had these seminars for the coordinators of the monitoring schemes, and this is also the first time ever in Finland, and it's been very useful, so we should really keep that up and keep on developing coordination. And this Lukki was already mentioned by Petteri. This coordination of the species monitoring schemes would probably fit quite well within the Lukki program. And this is the institutes that were included in this work, and you see a long list of names. So it's a large group of people, and it's really fun to work with these people. I mean, and it's quite easy to get people on board. The coordinators of these monitoring schemes, they understand the need for coordination and development. So some of the most important institutions being the Finnish History of Natural, the Finnish Museum of Natural History, us, the Finnish Environment Institute, Metsähallitus, the Forest, the Parks and Wildlife Service, and then the Natural Resources Institute Finland. Thank you.
Okay, hi everyone. My name is Tiina Laamanen and my colleague Veera Norros. We are going to tell you about eDNA and other molecular monitoring methods, how they are revolutionizing our monitoring and what we have done in FEO project. So first of all, I guess maybe all of you are not that familiar with eDNA, so I guess it's good to show you that it's really handy tool. There are many different ways how you can use environmental DNA. And what it is when we are talking about eDNA, it's simply a pool of genomic material from living organisms and their remains. And what is one really like a handy thing is that eDNA samples, they can be taken from, for example, water, soil, air, and you don't have to meet the group of interest by themselves. You can take the sample and then analyze it, and it really offers us a lot of different ways how to proceed and how to use this information to get the bigger picture what is happening in our environment. And just to mention that we are talking about eDNA, but also there are many other molecular monitoring methods, such as DNA metabarcoding, just to keep in mind that there are other as well. So maybe a little bit more in detail that why it's so interesting and so fast developing field, what we can get when we are using these new methods. So one thing is that we can improve the detection of rare, threatened or invasive species. There are many ongoing pilots and actions internationally. For example, invasive species monitoring. Then one thing is dark diversity. It's a really handy way to monitor poorly known or hyper-diverse groups. And when you have that kind of well-planned eDNA sampling, it's really cost-efficient way to monitor and get the bigger picture what is happening. And you can also use these new methods to monitor, for example, ecosystem or habitat state based on community composition. And you can do this with or without species identification. And one really important part of this ongoing development work is you can use these new methods for monitoring genetic diversity of target species. And then there are many new ways, for example, if you are interested to see more that what is actually, who are the active ones and how the ecosystems, how they are functioning, then you can use, for example, eRNA-based methods for that. So in FEO, we have done a lot. It has been many ways like a starting point for many our eDNA actions. For example, we made a literature review. On the next slide, I will give you a more detailed example on that. But one really important thing, when FEO started, we were organizing many national and international level workshops, because it's really important at the moment. This field is so fast developing and a bit of fragmented, so it's really important that we have that kind of national and international level coordination to get the understanding that where we are now and what we need to do, that we can get these methods into our, implement these methods into our environmental monitoring. And one key issue is standardization. We need common standards for that. And all these workshops, they were really fruitful, and it's really important that we are not doing it inside of Syke or inside of a national level. We really need to go into international level. And then quite soon when FEO has started, we realized that this eDNA field, it is so fast developing that we actually need this kind of a national eDNA roadmap, and it was really nice that we got a separate project funded by Ministry of Environment of Finland, and we made our national eDNA roadmap published 2022. And then with FEO we have had many different kind of pilots. We have had soil sampling, and we have done a lot of cooperation with our international partners. For example, Biospace project was one of our key collaborators. And then airborne eDNA, my colleague Vera will tell you more about that, but it's something that is developing really fast, and in FEO we have piloted a lot of that kind of research. And in water eDNA, in FEO we bought a eDNA sampling backpack, and we have had a pilot testing that backpack sampler. So, as I already mentioned, we did that kind of literature review where we look at all the scientific papers published last 7 years to see that where we are now. And we put those papers in this kind of technological readiness level scale. And we can see that basic technology is already developed and demonstrated in the field, but actually there are quite few cases in routine implementation at the moment. And in freshwaters and in marine environments, they are much further, and then terrestrial will follow. But of course, this is something that is developing really fast, and this will change within a few years. And then we made a questionnaire. There were a total of 171 responses to our international survey. And on the blue, you can see the national level answers, and in orange color, there are those international answers. And we can see that actually at the moment, there are so many ongoing actions, but there are some limiting factors. And the most important ones, they are lack of funding, lack of expertise, lack of method standards, lack of reference libraries, and cost of the analysis. But it's really nice to see that all of these are getting solved quite soon. For example, the cost of the analysis is getting down really fast. There are many cheaper options. For example, nanopore sequencer is really changing the field at the moment. And there are many ongoing actions aiming to standardize these eDNA methods. For example, last October, there were a GeoBond meeting at Montreal, and during that meeting, there were International eDNA Standardization Task Force was officially launched, and they are working really hard to get these methods standardized and standardized also like European CEN level and international ISO level. And for that, I give the floor to my colleague Ver.
Thank you. How are we doing on time? Sorry? Okay, excellent. So we're good on time. So in the eDNA roadmap that Tiina mentioned that we published in 22, we built on the results of the literature review that Tiina showed one result of, and also the results of the international survey and results from workshops. And we also included some data from the species monitoring related interviews that Päivi and Ape mentioned in their talk. And based on all of these sources, we developed an idea of the current state of the molecular method implementation in Finland, but then also a little bit of the international context through this international survey and this international literature review. And based on this kind of assessment of the state of the art, we formulated medium and short-term aims and concrete development needs, and then formulated concrete action plan for the next couple of years. And it was really great that we were able to do this in collaboration with the Natural Resources Institute, Luke. And in the eDNA roadmap, we included this kind of timeline on which we placed the actions that we proposed. The roadmap was published 22, so I'm not sharing the original version, but we have updated this timeline now. And this new version of the timeline is also now shared on this Luontotieto nature information portal that we will hear more about later. And I can take this chance to mention that also this nature data portal includes a whole lot of information on these methods, and also a summary of the current development projects that we know of. And if you know of more research and development projects in this field, please let us know, and we will include your project in the list. So in this timeline, we recognize that while we do want these molecular methods to become part of our routine monitoring, that they can also support research and also this monitoring that is required by our legislation. We are not quite there yet, but we are still in more this transition phase where we need very active research and development and piloting and testing. And this, of course, cannot be done with FEO project or any individual project, but is happening in very many projects at the moment. But then on this higher coordination level, there are also some actions that we propose apart from this broad field of research and development that's needed. And the most important ones I have highlighted here. So in order to also make use of this DNA-based nature data, we need to plan this data management on a national level in a comparable way that we are doing and have done with traditional nature data and species observation, for instance. Yes, and also, like Tiina mentioned, international standardization of methods and also solutions for quality control are very important things that we are trying to work on the national level in the international collaboration. And my final slide, just one highlight of one of the pilots that we have been doing in FEO,
is this airborne eDNA. And unfortunately, I don't have time to go very deeply into this, but airborne eDNA is very promising in the sense that air integrates terrestrial organisms in much the same way that water eDNA integrates aquatic environments. But there is the major problem of air movement, and that we don't exactly know at what scale we are observing biodiversity when we are taking airborne eDNA samples. And to tackle this problem, we have combined 2 observational campaigns with atmospheric modeling in collaboration with Finnish Meteorological Institute and also University of Jyväskylä. And unfortunately, I cannot share the results yet because it's still a work in progress, which will be continued in another research project. But we are hopeful that we will be able to make some kind of guidelines for how you should plan your sampling campaign to address a specific scale of interest that you want to target. Thank you.
Thank you so much, Tiina and Veera. Don't go anywhere because I'm sure that there are lots of questions. Tuija will be there with the mic. Do you have any questions for this group? There. Just hold your hand up so that, yeah.
Yeah, hi, Juha Seppälä from EIB again. On the eDNA, really interesting stuff. One of the things we're looking into is how can we promote the development of biodiversity credits? And would eDNA data be something that you could use to potentially, if there's money thrown at a certain area, is eDNA currently, or will it at some point, will you be able to demonstrate that yes, by fertilizing this area with money and having interventions done there, the species diversity or eDNA diversity has increased? Thanks.
Yes, thank you. Really good question, and good that you raised it up. I would say yes, we are almost there, and there are already some pilots which are aiming to do that kind of things. For example, there will be this kind of lake eDNA sampling campaign. They will take samples all across the world, and then they will use this information and then make like an economical value that what is the status of those sampling spots. So yes, and I guess this is because this is so easy to use method, and you can use, for example, basically whoever can take those samples if you have good instructions, so you can use citizen science-based approaches as well. So it's really promising, and we need to discuss more in detail.
I can say a word of caution to that as well, I agree. But so there's a lot of interest from private companies in this eDNA because it sounds so easy and objective and all of these things, and it can be, but we should be cautious because there's a plurality of methods, and you can also produce complete rubbish using eDNA if you are not doing it properly, and this is very important, and this is why we are really promoting this idea of developing shared solutions for quality control and developing this international standardization so that the data will be okay. Thanks.
I think we had a question here. No? Okay.
Thank you. Janika Bori, still. A follow-up question on that. Where are we with the development of producing these kind of standardized methods? Because, I mean, I can sense the interest for this, and I know there's going to be a lot of, interest around Europe in using this and starting to actually apply it. Because indeed, it sounds a little bit too good to be true. So tell us where we are and when can we have the first results?
Thank you. There are a lot of ongoing efforts aiming to standardize these methods. And for example, there will be ISO standardization meeting later on this autumn. So if we are optimistic, I would say that within already like 2 years, we could be in that kind of place where we can really, there would be standardized methods to follow. So, and we cannot wait too long because research institutions worldwide, they are already using these. So I guess we are quite of hurry that we can get that because there is a really big risk that there will be like a duplication efforts and those someone is using this method and someone is using that method. And for example, Water Framework Directive, we all know that it's not where we want to be. And for example, it's one example that Water Framework Directive, there will be like a 2026. I'm pretty optimistic that hopefully in next 6 years period, maybe we can already include some of these eDNA methods into there.
All right, thank you. I think we will have to move on now to the next presentations, but I'm sure that there will be more questions later, but hopefully they will be here to answer and continue the conversation. Awesome. Let's move on to the next fair topic, which is Earth observations. This work will be first introduced by senior researcher Pekka Hurskainen. And after Pekka, we first have researcher Tytti Jussila's case study about quantifying ecosystem conditions of aapamaias. And then researcher Janne Mäyrä is going to talk to us about the use of AI in detecting rare nature phenomenon. Over to you.
Good afternoon. My name is Pekka Hurskainen, and I've had the privilege of leading this work package where we try to advance the uptake of Earth observation for biodiversity monitoring. And I led this work package together with Saku Anttila. So acknowledgement to him also. So how do we start to advance? We first need to find the user needs. So, of course, to really advance the uptake, what we need is tailored, analysis-ready, and easy-to-use Earth observation products, which has a large spatial and temporal coverage as possible. But this is not enough. We need to have also a continuous dialogue between the EO and BD experts, and this, I think, my colleagues have already stressed this point. And it has to be continuous because the needs and the technology also evolves. So this dialogue will help us, Earth observation experts, to prioritize the data production so that we don't produce just anything, but what is really needed. And then we also get better understanding what are, for example, the reporting requirements. On the other hand, the biodiversity experts will understand better perhaps the limits of what we can do with Earth observation, and it can also narrow down the expectations. But yes, so this dialogue is helping both sides. So we have come to some kind of conclusion or agreement that the role of Earth observation is mostly supportive. So it's not the solution for everything, but we need also the field data, like it has been stressed already. And we have established the high priority needs around these themes, and you can see them there on the screen. Just to highlight a few of them. For example, land use around habitats is important to know how the land use has changed around the habitats because it affects how it functions. We also need to know certain variables about the forest structure, vertical and horizontal structure. We need water quality information and many other parameters we can get from Earth observation. So we also did document the workflows, how we work from the user needs to make the usable information. And just a brief example, the objective here was to map the extent of Annex 1 habitat types in northern Lapland. So we started with collecting the input data. So the Earth observation experts, of course, collects and processes the Earth observation data, but also GIS data into features. And the biodiversity experts then, of course, does the field work, which is so crucial in this work. And the user needs assessment helps us to, of course, do the right things to process what is really needed from the big mass of data. And then the in-situ data is split into training and validation set. We build a classification model. And then we based on how well this model works, we can improve the features or process new features, whereas the biodiversity experts then might need to supplement the training data with interpretation of orthophotos. And then finally, we are able to predict the model and do validation with the validation data. And the biodiversity experts also has a role here to give expert assessment of the results and usability. So it's a continuous process, and both sides are needed in all parts of this process. And the final product is, of course, the habitat type map. So just to conclude, some examples of the products we have done and used in the FEO project. We have done yearly mosaics of Sentinel-2 data. We have also used Sentinel-1 radar data. And from the Sentinel-2, when we have dense time series, we can calculate different type of statistical seasonal features. For example, NDVI vegetation index, we can get it on monthly composites, or we can do it also on yearly basis, so we can get maximum NDVI or the amplitude of the NDVI. So this gives us different perspectives of these habitats or their condition. And then on the national LiDAR data, which is collected from airborne instruments, we get the vegetation, vertical and horizontal structure information like vegetation height, canopy cover, or growth form classifications. And also some GIS data we can process into usable products, like from the forest inventory data. We did this proportion of deciduous trees and proportion of coniferous trees maps. And then we can also do more sophisticated products like very high resolution land cover maps with vegetation height included, or we can map the land cover in wetlands. So these are just some of the products we have done in the FEO projects. I think there were more than 30 different data produced, and all of this is available in the Syke open data, or either completely open or then for the use of the environmental administration. Thank you.
Okay, hello, my name is Tytti Jussila, and I'll have my topic today about our research on how to quantify ecosystem condition in Aapamires with satellites. And if we first look at these mires from air, not space yet, we can see that we are speaking of a very wet or even water-covered environment. These nutrient-rich and very species-rich mires cover large areas in the north. And basically all their functions are somehow related to this high water table level, everything from biodiversity values to carbon storage and gas exchange. And the variability of habitats along that hydrological gradient. But the most characteristic habitat in Aapamyres are these called flarks or rimpi in Finnish, these wettest depressions, or even water covered, at least at this time of the year after snowmelt and spring floods. Towards later summer, usually the water table level lowers a bit, but these flarks usually maintain very waterlogged to very wet conditions that provide a habitat for species that are adapted to this kind of stable conditions. As the ecosystem condition is so much tied to water, then also the threats are connected to disturbances in water availability. We are speaking of this kind of short-term shocks like droughts connected to climate change, probably increasing, and also some long-term changes. It seems, for example, that in southern edge of the Aapamyre occurrence zone, these flark areas are slowly shrinking. And another driver that causes these long-term changes is land use in surrounding environment. Intensive ditching, for example, causes disturbances to natural hydrology, and in worst cases, the water table level lowers. So there's plenty of motivation for monitoring wetness. Wetness conditions, its stability, and responses to all these environmental changes. And then, of course, there are EU directives that tell us to monitor the condition in spatially extensive national scale manner. And for this, we need to look at this from space. What we did in FEO was to develop a method for large-scale monitoring of wet surface extent by using Sentinel-2 satellite images and machine learning. So we trained a classification model to detect spectral signals that are linked to these flark-like very wet conditions. As training data, we used a large data set collected from aerial images by experts around Finland. And as a result, we then got this classification algorithm from which we can draw a single number condition indicator or one metric for condition indicator. In this case, the extent of flark-like wet mire surfaces. I don't know what would be a good reference for a good condition, but at least when we look at these classification rasters, we can say that those surfaces that remain wet throughout summer season are probably flarks, and if we would in any area or any region notice a decreasing trend in wet surface area, that would be a bad thing and a warning sign. So, after we had developed this classification model, of course, we then wanted to apply it to get these regional, or test producing these regional time series of wet surface area. At that time, in this project, we had 4 years of Sentinel imagery, each year there as a colored line, and for those 4 years, we calculated monthly values of our wetness indicator. We used Sentinel Hub cloud computing services to produce this indicator time series for each mire within Natura 2000 network, covering over 2,000 mires. And those we then aggregated to regional scale results you see there. And there we have very interesting information already. We see those seasonal fluctuations. We see varying conditions between years due to varying weather conditions. For example, impacts of drought, there on the red line, 2018. And these satellite-based methods really offer a very great, spatially explicit and extensive view of what is happening and where exactly. Like in those 2018 months, there on the lower row, we can now check from the map where are the mayas that were most affected by this hydrological disturbance. And those same areas probably will be the ones that are most affected by future disturbances as well. So, this kind of novel, very important information was already revealed by this short time series. Continued time series enable also these actual trend assessments to support habitat condition monitoring. And what is great advantage in these satellite-based methods is that the approach can be upscaled also outside the protected areas. And that especially is information we have not had earlier before these methods. So there is indeed great opportunities in this for really effective and informed conservation efforts. Yes, so this extended time series and extended scale outside protected areas is what we have been computing now this spring, so stay tuned for data publication. And also, if you're interested to dive deeper to these methods and the very interesting results, then go check our research paper published last year. And here I have also opportunity to thank all the co-authors and co-workers here. And then thank you for your attention. That was all for now. Thank you.
Good afternoon. My name is Janne Mäyrä from Quality of Information Unit in Finnish Environment Institute, and I'm going to briefly present two case studies about utilizing AI to detect rare nature phenomena, such as uncommon tree species and deadwood. And first of all, why are we interested about these two? If we want to monitor biodiversity, it's either really hard, almost impossible, and it requires going to the field. So we typically use indicators to quantify it. The hard part is that a lot of these indicators can only be measured from the field, such as how overall species richness or like individual species like birds or such. But there are some that can be detected remotely, and best indicators are those that tell about the opportunities for a wide range of species to live. But when I say that it is possible to map those indicators, it doesn't mean it's easy, because they are usually sparse, they are scattered, they are otherwise difficult to map, like both of the examples, aspen and deadwood, but more on that later. But then we have modern tools like AI and other remote sensing data. The data amount that remote sensing instruments, satellites, airborne data, UAVs produce, it's huge. And if you were to produce or analyze it by yourself, it would take years or even longer. But the AI methods excel working with large data sets. And during the last decade, the AI methods for image data processing, they are pretty much evolved into human levels or maybe even further. So for instance, there's an example from AI classification of dead wood from UAV imagery. And there's also the fact that depending on the source, AI enables to get real-time insights and analysis. For instance, there is one data set that updates regularly, which has 13 land cover classes, and it uses real-time, near real-time Sentinel-2 data. But to the indicators and the case studies, the first one is, of course, European aspen. It's the keystone species for biodiversity in boreal forests. Especially the large and old aspen, they host hundreds of species, and several of those species are also red listed. And there's an image that has a larger cluster of aspens from Evo, but they can also be found as single trees. And the current forest inventory data, they don't really separate aspen because they usually pool it with other deciduous species because it's so rare and it has a marginal role in commercial forest management. So for the case study about mapping European aspen is in IBC Carbon Project, we collected hyperspectral LiDAR data from Evo area, like 83 square kilometers, along with several hundreds or thousands of field measured trees, both from plots and individual. And we had a large number of aspen compared to compared to other data sets. So around over 10% of the trees which we measured were aspen. And we tested a large number of different methods. They had overall accuracy of 87%, but the aspen was surprisingly the easiest one of the trees to classify, which it had over 90% accuracy, and that enabled us to get the wall-to-wall tree species map from the whole area. That's, if I remember correctly, that's around 2.6 million trees which were detected from there, and around 3% of them were aspen, and we actually found a few aspen stands that we haven't been doing the field work there, but when we were able to afterwards ensure that they really were aspen. That's the one example of that. But then the other indicator, which is the deadwood, and it is the most important indicator for species richness, because around a quarter of all species in the Finnish forests depend on deadwood one way or the other. And it's even more challenging, especially the downed deadwood is important, but it's even harder to map accurately because the nationwide remote sensing data, not to mention satellites, is way too coarse for it because the Finnish airborne data from National Land Survey, it's 0.5 meter resolution, so pretty much 30. You can't really detect objects smaller than it. The only reliable way to measure it is to do field work, which is expensive, has limited coverage, and the down deadwood is also below the canopy, so you can't see it from above. And it's also really difficult to model because in managed forests, some of it's cleaned away, so you can't really model how it will naturally develop when someone goes and takes it away. So how do we map these things? We use UAV data because when you map cameras there, and then you are able to get 5 centimeter resolution data or even more accurate data. And in this case study, we had UAV data from 2 study areas, one in Hiidenportti, Kainuu, and then in Sudenpesänkangas, Evo. And for reference data, we manually annotated around 14,000 deadwood, both standing and fallen instances. And the state-of-the-art object detection models, they were able to detect most of the visible dead wood. Standing is of course easier to detect than fallen, but we are still trying to estimate that how much of the dead wood present can we even see from above. So that's when we get the manuscript ready, we hopefully have an answer to that. And then the fact is that both of the case studies I presented, they have limited coverage, so they are not really suitable from nationwide mapping. But when you have enough, for let's say UAV campaigns, you get at least species or deadwood amounts from larger areas compared to field work, where the boots in the ground mapping, and then you can then upsample them to Sentinel-2 resolution, something that get the percentages, so you can use them as the method to collect more field data. And next generation satellites hopefully will have more accurate spatial resolution. The most accurate commercial satellites right now have 30 centimeters, but they only have like 4 spectral bands, so maybe someday we have multispectral or hyperspectral satellites with that kind of resolution, which enable us to detect the rare species from satellite images. And then here are the references and acknowledgements. The other projects in addition to FAIR were IBC Carbon and FinPIFIRI, and there are a list of the manuscripts. 2 of them have been already published, and hopefully a 3rd one in this year.
Please stay here, because I'm sure that there will be questions for you. Can I ask Pekka and Tytti here as well, do we have any questions for these 3 about these presentations? Here, Tina's going to run with the mic.
There's one in the chat. Timo Pyhälahti is asking, should gathering of test and training data for AI, Earth observation and DNA, etc. novel methods be concentrated on selected example areas to synchronize with development of biodiversity indicators and fieldwork?
Yeah, that sounds like a good idea. No, I think it would bring really good benefits, and yeah, definitely. Now we need a coordination mechanism for that. Do you have anything to add?
Any other questions here? Okay.
Thank you very thank you very much for extremely interesting case studies. You emphasized the need or the crucial importance of kind of field referencing and you know the combination of field methods with remote sensing and so on. I was wondering, is the change in the environment a challenge? Do we need to repeatedly train the method? For instance, the case of identifying aspen, you know, crowns of aspen within the canopy. What if the species composition, or not if, when the species composition of the forest changes? You know, we will have more broadleaf species coming in. Does that you know, mess up the computer, basically? Do you need to retrain it periodically to be able to reapply? And that may also be the case with Aapameyers, for instance, if the overall you know, water level goes down and kind of the reference level changes. So do we need repeated training sessions to be able to use these methods?
Yeah, that's a good question, and I would say that yes, the models, no matter what they do, they need to be retrained periodically. For instance, if the species composition changes and when we get new species, the example models I showed there, they only classify things into 4 species. So the model, if it sees something, it always thinks that it's one of these 4. So if we want to get like more species to get recognized, then we of course need more data and new models.
Yeah, I wouldn't be so sure if it's like fully necessary. Maybe all the cases are there already, so they are included in the training data, but of course always training or having more training data improves the models. So that would be necessary anyway.
Thank you. I'm sure that this conversation will continue over coffee in about half an hour, but we have one more set of presentations for you, but let's clap for these guys first. Thank you so much. This last set of presentations before coffee break, these are introductions to FEO's work on modeling. First, we have the leading researcher Risto Heikkinen talk to us about biodiversity models, and after that, senior researcher scientist Virpi Junttila presents about carbon balance and regional land use scenarios. But Risto.
Yes, good afternoon from myself also. And I start by making this notification that this presentation includes also contributions from Veera. And let's see how it goes. Okay. And also I start by making sort of skip out of this FEO context to one of these Ceobon working groups. It's called EcoCode, with very recent working group. It had some workshop in last year, and they kind of wrote some findings of their discussions, and I pick up 3 of those findings, which are listed here. So we need multiple models for the same question was the first one, and then there's this highlighting of the scaling mismatch between model projections and management, and also this need of model-based indicators. So these are valid points, perspectives also for FEO as well as all modeling, biodiversity modeling work. But what is the biodiversity models? Actually, it's extremely wide field of different models. So which means that I can only scratch the surface of this topic and use a couple of selected examples. To start with one of the most commonly used modeling kind of approach currently for biodiversity modeling, species distribution models, it's called Maxent kind of a modeling. And this was used for developing wall-to-wall predictions of forest stands which are having biodiversity values. So we were focusing on 6 forest species, bird species, which are indicators of biodiversity values in the forests. And we gathered this information for this forest characteristics across the whole forested Finland on a spatial scale of 96 by 96 meters. So this kind of scaling is useful for conservation planning and management planning. So therefore it includes a couple of million different grid cells for this modeling area, but anyway, the Maxent can handle this kind of data sets. And also, it's good to know that we were focusing on nesting sites of the bird species, which indicates that these nesting sites are the most valuable kind of from the bird's perspective, and therefore they can be very highly important areas for conservation planning. And this visualizes how this modeling is done. On this left lower corner, you can see this kind of zoom in for one of these modeling issues that we were using something like 20 different predictors for the bird species. And stand volume, for example, was one of the important one for this three-toed woodpecker, which Janne also mentioned. But also for this final model, we gathered something like between about 8 or 10 different predictors for each of the species. And this kind of illustrates that all these kind of predictor variables, importance for the species, sort of habitat suitability of the species, were put together by this Maxent model. And here's a couple of examples also for these 6 modeled bird species, indicator species. The first one here on the left-hand side is this picoid tridactylotis with this three-toed woodpecker. And you can see that it's having this most suitable forest patches more concentrated in certain areas in Finland than, for example, this Accipitter gentilis goshawk, which is a little bit more relaxed on this kind of habitat demands of the species. And also, if you zoom in certain areas closer to this sort of spatial resolution of this 96 meters by 96 meters, you can see there are also differences between woodpecker species. There's two woodpecker species on these 2 zoom-in figures, the most highly suitable areas for those 2 species. And you have differences also on those most suitable areas. Which means that using this kind of information of several species, you can get more kind of multi-diverse picture of the most important areas in the forest landscapes for conservation planning. So these model outputs can very nicely complement each others. And this kind of information can be used as a sort of kind of let's say this feeding material for conservation optimization analysis like zonation type of analysis. But the good things are in this kind of a modeling approach is that this enables us to fill in the spatial gaps in biodiversity information, this kind of modeling approaches. And also these impacts of change in landscape, land use can be assessed using this kind of modeling. And this Maxent model is good in that sense that it can handle presence-only type of data, which is really quite important aspect for the modeling approach. But the limitations, there are limitations. There are spatial biases in the species data which needs to be considered. And this kind of wall-to-wall environmental data can be quite difficult to get. And also this between model comparisons can be quite challenging. The second example, actually this goes sort of time before FAO actually, but it's still valid approach currently. And it is focusing on the impacts of climate change on species and how to model them. And it has been observed that this kind of output from bioclimatic envelope models can vary very much between different modeling approaches. So one way to handle this kind of uncertainty is to make ensembles of different models, which means that you can make ensembles of different modeling algorithms outputs as well as ensembles of models which are based on different sets of predictor variables, which has been this kind of approach we were using together with one paper together with Maria, which is listed here, shown here. And then when you have this kind of predictions from several different models, so you simply stack them together to find out the areas where the models are agreeing most. And this kind of approach we used for modeling birds and the climatically suitable areas for the birds in the future in Finland. And there was 100 bird species which were modeled. And this Stringa clareolasa, for example, is one of the examples. And we also linked this climate kind of predictions against this habitat suitability of the species. And this figure tells us that in the future, the most suitable kind of species-specific areas for the Stringa clareole are occurring in these reddish areas on the left-hand side map. And if you compare that with the protected areas, which is the habitat for the species, they are kind of quite nicely coinciding, which means that for this species, there's perhaps not so dangerous situations ahead in the future. And there are also some bird species like this middle spotted woodpecker, which is not breeding in Finland yet, but it has the capacity to enter the Finland in the future with the warming climate, and we can actually now predict where are the most suitable areas for the species and then go and check whether there's suitable habitat for the species, and if not, then sort of new conservation kind of efforts might be targeted in those areas. So the benefits of this approach is that it really supports conservation, targeting conservation actions to continue to new focal areas, and detecting areas where the model kind of outputs agree mostly, which give us sort of confidence of the most important areas for the conservation. The limitation for this approach is that this type of climate species model or species climate models are quite broad-scale models. So typically, they are ignoring this variation in topo microclimate, and also they don't provide very much information about the species dispersal and population kind of persistence capacity. And how to get some sort of information of the species population kind of persistence capacity, then you could make a sort of extra step to get into these population dynamical models. And that's where we have one example of that for one specific grassland specialist butterfly, Maniola jurtina, meadow brown, which is occurring in semi-arid grasslands. And this map on this left-hand side, it's telling us that this suitable, climatically suitable area already currently is this area in the southwestern coast of Finland, which is indicated by gray color there. But if you go and check these blue dots, which are indicating these known occurrences of the species, it means that it has more climatically suitable area landscape in Finland, and it's not kind of species is not occurring there yet. So that's kind of situation we can model using population dynamical models. And we did this one exercise using Redshift type of model, which simulates how the species population thrives in certain landscapes. And they're using information about how much there's habitat cover for the species, what is the carrying capacity of this habitat, what is the population growth rate, and what is the dispersal ability of the species. And these three figures on the right-hand side, you can pick up two important information from them. If you focus on this uppermost figure, which is telling us that if the species has very low growth rate, so the population is kind of growing very slowly, then the species have very high difficulties in kind of persisting in Finnish sort of semi-arid grassland network currently. Okay, so the habitat cover is shown on this x-axis, which means that the higher the habitat cover, then it has, of course, it increases the persistent capacity of the species. So this kind of modeling really enables population persistence kind of estimates, and in also determining habitat restoration needs and that sort of things. But these methods are really data hungry, and there are kind of gaps in species trace data, which also complicates their application. So the final two slides, they are actually made mainly by Veera, and that's kind of examples of one of the cutting-edge multifunctional static correlative modeling approach, which is called hierarchical model of species communities, a joint species distribution model. There's a couple of others also which are doing a little bit similar things, but this one is the most kind of complicated and kind of multifunctional type of species community modeling approach. Okay, that sounds challenging. So this model is really taking into account not only species, their environmental drivers, but also species traits as well as phylogeny of the species. So that's really something with. Actually, I have 3 still. Okay, but so Veera has been doing this kind of a modeling exercise for projecting marine kind of phytoplankton communities and the changes in them, and how this environmental data is driving those changes as well as climate changes driving those changes. So 3 different adaptive strategies for land use and 3 climate change scenarios. And this is the final slide. So this is kind of summarizing information of this hierarchical modeling of species communities type of exercise for these phytoplankton species. And simply, if you don't pick up anything else from here, it's this nice rounded figures, these circles, and the one on the right, it's telling us what is the main driver for the species. So climate change seems to be the main driver for the species and their changes in these phytoplankton communities. And the other circle is kind of giving us indication whether this kind of direction of the change is consistently same in different scenarios or not. And what is quite nicely done here, you can see this taxonomical tree, but also these colors on these lines. You can check that this, for example, this climate change-driven species, you can check which of the species are climatically driven by those colors, these orange colors, and which are land use-driven species. So this is really nice way to kind of summarize this kind of this kind of information in a sort of very, very condensed way. So, okay, thanks.
Okay, hi everybody. My name is Virpi Junttila and I will continue about modeling, and I will go to ecosystem modeling and carbon balance and how these ecosystem models can be used together with the biodiversity models, for instance, in optimization of conservation areas. So first a few words about ecosystem models. So basically they are simplified mathematical representations of whole ecological systems that we have. So not just single species, but many species interacting together and having some kind of relations. So the range of the modeling can be from individual population to even an entire biome. And why we have these models is that they may contain complex ecological relationships, and which are really difficult to kind of evaluate if you don't have modeling on the background, if you have some changes happening there. The relationships can be things like sunlight and water availability to photosynthetic rate of the plants. And we can use these models to better understand how these different actions affect to the ecosystems and what will happen there. These drivers can be like weather and land management, which I will talk about soon. We can have then scenario analysis and maybe analyze also the uncertainty of the predictions that we make. And I'm going to talk now about one specific ecosystem model. It's a forest ecosystem model, PREPAS, which is developed in Helsinki University. And it's a process-based model, which means that it's not that data hungry anymore after it's been trained. So they have been using measurements to train the model, and after that we can use it everywhere in the similar conditions that where it's been trained. And it models growth, photosynthesis, respiration, competition between different tree layers, carbon cycling of trees, ground vegetation and soil. And the drivers in the model are climate and management of the forest. And it's a spatially explicit model, so it's basically, we can use simple pixels to model it, or the multiple pixels, and see in spatially explicit way what is going to happen if we do different things there. And I will show now some examples for how we can use that kind of modeling. So here we started to simulate the whole forest of the whole Finland from the multi-source national forest inventory data, and started to see how climate change and different management scenarios affect the forest growth. And here you can see the tree biomass development with different scenarios. So on the left-hand side, you see the current situation of the tree biomass, and you can see then if we continue harvesting the forest as the way we have been doing now in the regional level, then how we can, the forest will not basically grow very much, the tree biomass remains pretty similar, and you can see, for instance, in the southeastern Finland that the tree biomass is not actually even growing there. But if we would stop harvesting completely the forest, we can see that there is much capacity to the tree biomes to grow a lot, and the climate change will increase the growth if we discard the disturbances which are not included in this model. We can also model the uncertainties over the different scenarios, and you can see here that there are different harvest scenarios included, and here's the total carbon storage in Finnish forest over the time until the mid-century. And you can see that there is potential for the carbon storage to be much higher than it's now. But if we keep harvesting or even increase the harvest levels, then the total carbon storage will decrease. But there is a lot of uncertainties included here, and it should be more discussed in public also, that we don't know exact one value of what is the carbon balance or what is the carbon storage, which is often neglected in the public debate. And we can use also this kind of analysis from models to get this kind of carbon balance flows. So here on the left-hand side, you can see outputs from different types of models of the carbon sources of the greenhouse gas sources of current situation of the whole Finland. There are different land use categories there: artificial surfaces, arable land, forest, water bodies, and wetlands. And on the left-hand side, you see the sources, and on the right-hand side, you see the sinks. And if you want to be carbon balanced, then these should be equal. And now you can see that the sinks are much smaller than the sources at the moment. And this way we can get a better picture of what is the scale of different sources and how can we tackle this problem of climate change in Finland. And we can do this also in region level, so we can see how different regions in Finland differ from each other and what is efficient there. Okay, then I will talk about how we can use this kind of ecosystem modeling together with the biodiversity values in conservation prioritization and in overall in the biodiverse models. Okay. So basically, you saw earlier in the max-end modeling, which Risto was showing, that there were a lot of forest values or forest variables included in the model. So we can include them also from the model PREPAS framework to the max-end. We can see how the the maxent outputs change, for instance, under climate change, or if we do different management scenarios, what will happen there. And we can also model the deadwood potential because we have this competition modeling in the PREPAS, so we can see where might be more deadwood and how it would affect, for instance, the indicator bird areas. And we can also use these outputs from PREPAS and Maxent in the priority setting model zonation, as Krista was mentioning earlier, and see how, for instance, different kind of settings affect where the best conservation areas could be. So we can put in PREPAS, in zonation different layers, and we can use, for instance, the PREPAS output for carbon storage and carbon sinks of forest there. We can use Maxent indicator species outputs, and we can use forest data from for instance, the NFA data. And then there can be a penalty layer for the forestry measures. So if there has been some management recently in the forest, then there can be penalty, which is then affecting the optimization routine for finding the best biodiversity areas. And in this project, and together with IPC Carbon, there was analysis where there were only biodiversity layers included, there were only carbon storage and sink layers used, and then combination of those. And on the left-hand side, you see that the biodiversity values were more widely distributed, but more local. So they are basically all over Finland, but they are very local. But the carbon values are concentrated more to the southern Finland, where the forests grow faster, and the volume can be wider. So if we want to take both of these layers, or both of these biodiversity and carbon included, then you can see that actually the biodiversity is making the decision where the best areas would be for conservation. And so we could use this kind of approaches also for under climate change and see how this will change in future too. Okay, that's all I had. And here is, if you want to see more information, there are references from the publications we made. Thank you.
Thank you, Virpi. All right. Any questions for Krista and Virpi? Very quiet. Are you so thirsty for coffee now that you don't want to ask any questions anymore? Okay.
It's just that there's quite a lot to digest in these talks, and so it takes some while to formulate a question. Is it really working? Okay. And I'm still working on formulating it. But I'm trying to look at this from a decision maker's point of view, and it's from a scientist's point of view, it's thrilling to see all these possibilities, and it's easy to see the value of testing different approaches and so on. But a decision maker, of course, looks for applicability and is often impatient. The problem may be right here at hand. And so what I'm trying to formulate a question on what would you tell that decision maker who needs you to advise him or her right now? How close are we to an actual applicable methodology? Can you condense already those trials into something applicable, or can you pick okay, this one approach is good enough and ready enough, go ahead, use it? Would you be able to comment on that?
Oh, that was quite a wide question. About the carbon balance so outputs, we have been actually doing something like that. So we have been showing region level results of how different management levels would affect carbon sinks over the regions. But the uncertainties are, of course, there. So it's a difficult thing to discuss with the decision makers. But I don't know. Maybe Risto can tell about the species.
Okay, for this species distribution modeling type of approaches, the situation is still quite challenging because there's so many of different models, and let's say that all these different models, they have their own kind of campaigns that the kind of model researchers have been used this kind of modeling approaches, and they are sticking to their own kind of approaches and advocating them. And there has been several different reviews, and still it's so that let's say that in most of the cases you should perhaps try a couple of different modeling approaches and see whether your kind of outputs from the models are agreeing or disagreeing. If they are agreeing, then you have some certainty to take it to the decision makers, for example. But of course also the modeling kind of approach is not the only tricky thing. There's several other tricky things in modeling kind of biodiversity. It's full of kind of pitfalls, and you have to know something about those. And then when you have some certainty that, okay, now you have this kind of recommendation for the decision making, the extra step which is always need to be made is the validation in the field, so that the predictions are not taken as a sort of face value. Okay, there is biodiversity and there. We don't need to check whether there's valuable things happening or occurring there or not. So that it's also this validation is one of the key things, and hopefully there's time for doing that also. But of course, in some cases, the issues which are modeled, they are so straightforward that all these different approaches are agreeing. So then you have a lot of kind of validation or sort of confirmation in your kind of recommendations for the stakeholders. So it's not straightforwardly easy thing.
Now I have a few extra minutes to formulate my question, and I'm also a few more minutes away from the coffee. So I'm formulating a nastier question. Do we actually do anything with those models? Since there is the layer of reality is missing. For instance, the forest biodiversity values and carbon values, and then there is the layer of land ownership. And there is no decision maker that actually could make use of those optimizations because they have to take what they can, you know, if they want to protect something, for instance. So is this too sophisticated a tool for the problem at hand?
Is the mic a hot potato again, or?
Yeah, that's possible in certain cases. Really, it can be a little bit overly sophisticated for sometimes. But let's say that I can transfer this question to Joona, because Joona is a decision maker. So, do you wish to say something about this? How to kind of take into account zonation-based recommendation for conservation planning?
Thanks for the hot potato. And just for the background, I do have a PhD on the topic, and I'm not even kidding. For the most part, I think it is too sophisticated. But then again, the field of decision making is pretty broad. There's, as you were implying, Risto, there's also various kinds of decision makers. I'm sure that the Prime Minister wouldn't want to see these maps or couldn't make use of them. But for example, when the conditions are right, I do believe that they do have use, for example, within the environmental administration. It's true that, for example, land ownership is one complication that is hard to come over. But, for example, when we're considering state-owned forest land, for example, where to put new protected areas. That's the classical example. And Leif, you were asking whether they are in a state that they can be put into use. They have been put into use already more than a decade ago, so the answer for that is straightforward. Yes, they can.
And also one aspect is restoration, because if we, in Finland, we are going to kind of head at, in this kind of area of where to put new restoration areas, these models can give us some information that what are the most potential site locations for restoration.
All right, one more quick question.
Hi, Juha Seppälä again from EIB. Luckily, I only have a master's in ecology, so I can ask very stupid questions, unlike Jona. You were talking about the indicator species. Has there been talk about kind of distilling down the number of indicator species to the smallest kind of set possible? I know we heard from APA about the different habitat types and each have their own indicators, but has there been any kind of talk around narrowing it down to as few as possible? Thanks.
Actually, I don't know about that sort of process and would be perhaps a little bit skeptical about that because the different indicator species are actually indicating different elements on the habitats and environment. So therefore, I would be a little bit hesitant to narrow it too down in some, let's say, in a very small set of species, for example. Possibly something like that, certain sets of indicator species for certain habitats and another ones for different habitats. That might be something which could be useful. Do you wish to add something also?
No, I'll present on that later.
Okay.
So the answers are coming. All right, thank you. Amazing. All right, there's coffee served in Myllysali, so where you picked up your lunch as well. Please be back here in like 5 minutes to 3. So 25 minutes break. All right. Let's prepare to continue. I'd quite like to know how many liters of coffee does a room full of scientists drink in a day. I think it's quite a lot, especially when we start that early. And I wonder if it differs between scientists and, I don't know, policymakers? Yeah, can someone model this for me, please? Okay, so this next hour and a half or so, we have a few more sets of presentations for you about FAIR's work. Next up, we have a set of presentations on data management and interoperability, which will be introduced by coordinator Urpo Leinonen. After that, senior coordinator Ida Autio will demonstrate the Nature Data Portal.
Yes, good afternoon. I'm Urpo Leinonen, and I'm from the Digital Services Unit of the Environmental Institute. And I'm here to present about the work that we did in the FAIR project related to data management, interoperability, findability, and in general, the shared use of nature information in Finland.
Kano, eikö se pitänyt tulla tästä?
Nyt. Mene hetki. Etenä mitään se on.
Well, what an exciting day. Well, maybe we can take a couple minutes of technical break here at this point, so please continue your conservations and we try to figure this out. Okei, nyt tapahtuu jotain.
Katsotaan.
Fingers crossed. Okay, let's try again. And in addition to myself, also Kirsi Valanne and Eetu Jutula have been contributing to leading this work in the FAIR project. So we took as an example case in FAIR these natural habitat assessments because it's a good example of an effort that experts need to do every now and then to gather nature information together from various sources and different organizations. And it's not always straightforward to compile this data and put it together and get an analysis on the state of nature. And we did workshops and interviews. At the beginning of FAIR, to find out what are the key areas of improvement in this process that the experts identified. And we tried to use that example to find out what are the actions that we should take in FAIR to make it easier for the researchers and experts to use nature data jointly in Finland.
Yeah, that would be one option, but I think only a couple of us have computers today. Oh, well, this is very unfortunate. Yeah, we already tried that, but maybe we can use the mobile. Is the link to the screen? It's on the website. The slides will be shown on the screen. Not sure where they are like open. What if we are going to change the computer? Does that help?
Let's try. Do you have your slides in yours?
Yeah.
Joo, katsotaan. Voidaan myös kokeilla. Kokeillaan ensin tämä ja sitten.
Mulla ei riitä sitten akku.
Mutta jos toi laitetaan sulle, onko sulla hetki?
Woohoo!
Tässä on laturi. Tässä on nopea pelli.
Okay, let's try again. So through this example, we gain more information about the challenges in the shared utilization of biodiversity data in Finland, also in the whole. And these challenges can be examined through the FAIR principles of data, which are findability, accessibility, interoperability, and reusability. So finding and utilizing the nature data is often difficult because it is so scattered across the different organizations and information systems. And this is just due to the lack of coordination in the past. All different organizations have been working kind of separately from each other in these data management and sharing issues. So this is something only collaboration can help in. And the challenges in data accessibility arise partly from the fact that the data is not always even in digital format. And even if it is, open interfaces where the data is shared may be lacking. And the interoperability of data is, of course, a crucial thing for integrating the data. And in the case of these natural habitat types, there is no common terminology, and the interoperability is thus lacking. And if we had standardized and comprehensive metadata, that would also benefit the data interoperability, but also the reusability of the data. But this too varies greatly at the moment. And here are some examples of what was achieved regarding this fairness of nature data in the FAIR project. So, like we have heard, a lot of old data was digitized and published. Also, new data sets were produced, such as the remote sensing data. There were many data sets that were published from the older habitat assessments that had not been published before. And all that data was then published with comprehensive metadata for better availability and accessibility. And to facilitate the natural habitat assessments, we also developed methods to automate the retrieval process of some data sets. And we also automated some or created some methods to automate the documentation of data processing to make it easier for the metadata production, which often is something that the researcher or the expert doesn't have so much time to do. So we are trying in this way to facilitate it for the coming natural habitat assessments, but also other use cases. And an online service, Luontotieto, which in English we translated the Finnish Nature Information Hub, was established to bring all this data together that FAIR project, but also other sources and nature data stakeholders have produced. And this contributes to the data findability. And you will hear more about this Luontotieto web service in the next presentation. And the collaboration around advancing the interoperability and also the fairness of the nature data in whole has now made a promising start in this FAIR project. But it's something that requires more long-term work and joint efforts between the different organizations. So hopefully some projects that have now started can continue this work, but also the hope is that this Lukki network can be kind of the platform where the interoperability work can continue now in the future. And that's all I have from my part at this time. Now I would like to welcome Ida to tell you more about the Luontotieto website. Thank you.
All right. Hello, everyone. As Ulpu mentioned, I'm going to tell you more about the Finnish Nature Information Hub, which is a web service created in FEO, and I will do a short demo. But first, a few words about the service. So this service brings together Finnish biodiversity data, and it also gives insights to nature monitoring and methods, as we have already heard today, and then the use of nature data. It's developed to promote the findability and interoperability of biodiversity data in Finland, and it aims to gather existing nature datasets under one service, bringing the data from its original sources. And it's actually launched officially today, but the site is still in development phase, kind of as a prototype. So it would help us a lot to continue this development if you visit and comment, and I will show you how a little bit in the demo. But before going to the demo, I'm gonna guide you through the sections first in the slide. So there are 3 sections which are presented in these boxes: data search, monitoring and methods, and nature now. And the question behind the topic, below the topic always is something that we try to answer in these different sections. So the data search, it's what nature data exists and where can it be found. So this service brings together metadata, which means the descriptions of the data. of nature-related datasets, and it guides the user to the original sources of the data. It has data from different organizations. At the moment, there is data mostly from Syke, but also from Luke and Laititokeskus. Data from those can also be found at the moment. And the data can be searched with keywords, and the search is assisted with filters, data type and data theme. I will tell more about those in the demo. Then we have the monitoring and methods section, and the question there is what methods are used to collect the data. This is divided into two subsections, current nature monitoring schemes, nature monitoring methods, and evaluating the uncertainties of nature information. The third section is called Nature Now, and the question there is what does the existing data tell us about the nature and its states? So this section brings together a collection of links to websites that have up-to-date information on, for example, the state of nature, threat level assessments, where this nature data has been used. And now we'll go to the demo, and please cross your fingers for me. For demos and live presentations is a risky business, but let's see what happens. Skip. Okay, not yet. All right, here we are. So this is the main page of the service. Oh, shoot. We tried before with the other computer, but no, this one is... Should I have to maybe cancel these? You need to exit that and then... Okay, oh, great. Yes. All right, so we have different language versions. Finnish is more complete, and we have started translation in English, but it's finished enough that I can demo there. So the main page looks like this, and the three sections that I just talked about can be navigated to from these boxes here, and also the bar here at the top. And I will go through them all quickly. So the data search is here. Let me... All right. Let's just skip all this. Yeah. So there is some general information, and then there is the search tools. So we have a free word search, and then these filters that guide the data search. And before you have made any searches, you get all the data that's here at the moment. So today we have 308 datasets or their metadatas. And then I will just quickly show you an example. And in my mind is a dataset that I know quite well, which is the land cover, Korean land cover dataset that Syke is producing. So I'll demo with that. So if I'm trying to find data related to that, I can type it there, and then I get all the data. And it's searching the topic, but it's searching also the contents of the metadata. And then I open the metadata document, and here it is. So we are bringing, first we have some general information about the dataset, and this is all metadata brought from the original sources. So that means the organization that's actually updating the data and the metadata. So we have a general description of the dataset. Then we have information on who's responsible of the data, some contact information, then some temporal how often is the data updated, or when has it been updated. So in some cases we have some temporal scale, at which time scale does the data cover. Then we have some processing information. And here we have data and resources, which means that if the data has some download links in the original metadata, they're also brought here. So, but it doesn't apply to all data. And here is a good example of how this kind of technically work. So all of these metadata is brought from their original sources. So if it exists in the original source, we can have it here. But if it doesn't, we are not creating anything new here. And the good thing about that is that we don't have to manually update any information in this search, but they come, they're harvested from the original sources, kind of decentralized and brought to this site. And in the end, we have some information on the metadata, so who's responsible of that, and then also link to the original metadata site. And there might be some additional information, but we wanted to keep this metadata site of the service quite simple and clear, but then you find your way to the original sources and maybe find some other information. Then I'll show you the filters. So if you're not completely sure what you're looking for, but you kind of know something, something about what your needs are, we have data type and data theme. So data type is roughly about how the data has been produced. And the logic is not solid, but here, unfortunately, these are still in Finnish, but we have, for example, citizen science, remote sensing, some museum collections, laser scanning, and so on. So you can choose from those. And the data theme groups the data by kind of the topic. So here we have climate, Baltic Sea and the coast, rocky habitats. And here I can demo maybe that one. So if that's what I'm interested in, I can choose that and then press search, and data that has something to do with rocky habitats are listed here that are at the moment in the service. Yes, so that's about the data search. And then I'll show the other sections. So I'm going back from the front page. So monitoring and methods was shortly talked about in the previous presentations, but here we have 3 subsections. So current nature monitoring schemes, nature monitoring methods, and evaluating the uncertainties of nature information. And in the monitoring schemes, we have collected them in subsections based on kind of the ecological level, so species, habitat, ecosystem process, and genetic diversity monitoring. And I will just show one of them, and this is actually what Päivi and Ari-Pekka already had some screenshots on. So there is information about this type of monitoring, and then these lists of active monitoring schemes are in the end grouped roughly by the species group. So here you find these lists of the schemes that we have at the moment. So this information can be found there. And then the rest of this section, we have collected or put together methods. And we have 6 of them here: field observation, remote sensing, and so on. The eDNA that Vera and Tina were talking about is here. So there are quite extensive articles or content about all of these. So this information can be found. Unfortunately, not all of these are yet in English, but they are to come. And the third section of this monitoring and methods is an article about evaluating the uncertainties of nature information. Yes, and the third section is called Nature Now, and it brings together a collection of links to websites where there are up-to-date information on how the nature data has and can be used. For example, to determine the state of the nature or make threat assessments. So those are collected here. There are not so many yet, but this is also under development to gather more. Yep. And one important part that I still want to show you is the contact information that can be found here. And it's me at the moment. But please, when you visit and you have comments or questions or suggestions, send me an email and we'll try to take those into account when we develop it further. Okay, then I go back to my presentation. Hold on. Yes. And actually here I have a backup plan of screenshots, which I can now skip, which I'm very happy about. And I only have not 6, but 1 slide, which is about the next steps of this service. We are planning the development of the service in other projects. FEO is ending, but it's not the end of this service. So there are for example, biodiversity, Finbifiri and Lukki work that is continuing this development. There are also some international cooperation in sharing biodiversity information, and this can be used as an example in those cooperations. And very important part of the further development is to improve and to continue the cooperation with other organizations, that more data can be found in the data search. And we have also thought that this is kind of an example and works as a display window to the goals and challenges of data interoperability. So if a metadata is not available, or it's technically not accessible, or the metadata model is insufficient, it cannot be found or presented through this kind of services. So there kind of we point the problems through this kind of practice that making this service has been. And I also want to mention that Syke is committed to the maintenance and development of Luontotieto. And there will be some more organized also user feedback work to be done, so stay tuned. We will collect user feedback and focus our development with that. But thank you.
Thank you, Ida. All right, with all these technical difficulties, I think we're going to join the last 2 Q&A sessions. So I'm sure that you have lots of questions for Ida and Ulpu, but keep those in mind and ask them after the next set of presentations, please. Yeah. And the last set of presentations for today is all about putting these developed methods into practice. First, we'll have researcher Heidi Lehtiniemi to give us an overview of FEO's work on policy. Then we have 2 introductions to FEO's work on application. So first, about the use of biodiversity data by senior researcher Pekka Vanhala, and lastly, senior coordinator Aapo Kahilainen will talk to us about indicator pipelines. But Heidi, thank you.
Hi everybody, on my behalf as well. So I'm Heidi Lehtiniemi, as was told, and our work has been a little bit different than everybody else's. So we have not been focusing on many species, but just one, that's humans, and how they use whatever it is that we're producing as biodiversity information or knowledge. And you may also notice that I'm using a different word than many others before me. I'm not talking about data or information, but knowledge, but more on that a little bit later. So biodiversity knowledge in itself is in a bit of a transition. As we've already heard, there's a very increasing pressure from the private sector as well to use and produce knowledge, but also that means that the users of biodiversity knowledge are becoming more broad, and not all of them are experts in biodiversity knowledge, which obviously then changes the use of the knowledge as well. So we have gathered quite an extensive material of the use of biodiversity knowledge in Finland. We have over 50 people's views, and these people all use biodiversity knowledge or information in their work. And based on this material, we did an analysis on how they actually define biodiversity knowledge. There are many different meanings that it gets, and that also affects the use of it, but then also how is it used in different contexts, and I will give you 3 examples. But yeah, to start it off, what it is that we're actually talking about when we're talking about biodiversity knowledge. And I'm happy that Jannik already mentioned quite a few of my points here, so maybe this is just to tell you again. So first of all, it's data on especially species, habitats, and ecosystem processes, the nature itself. It can also be information on the impacts of various activities on these natural processes. And third of all, it can be knowledge on the ecological effectiveness of different societal instruments and policy measures. And then last of all, sometimes it's wisdom regarding what should we do, which is already quite far from the original what happens in nature. So just to keep in mind, we're often talking about apples and oranges when we're talking about biodiversity knowledge, or especially in Finnish, luontotieto is quite a broad word. So it has many different meanings within it. And then just a few words about the different uses, the contexts of knowledge use. So first of all, we have the instrumental use of biodiversity knowledge. This is the kind that's fairly straightforward. It's institutionalized. We have really clear knowledge needs, and we have been producing knowledge to fill those needs. It's typically done by professionals, so it's all in all fairly straightforward, well-known, and we've been doing it for a while, so we're good at it. And I'm happy to tell you that in our material, we only had successful examples of this kind of knowledge use, so we're doing this really well. So the main challenges related to instrumental knowledge use were regarding to data properties or coverage, or then different administrative issues, just such as allocation of resources, so fairly practical things. The second context is conceptual use of knowledge, which is already a bit more complex than instrumental use. So the application and adaptation of the data and information actually needs to happen before it fits the context. And this kind of knowledge use, it's typical that we want to include multiple perspectives. So we want to include carbon and biodiversity, maybe pollution, something else, which requires way broader expertise than just focusing on biodiversity itself. There were both successful and unsuccessful examples of this in the material. So it can be done, it has been done, but we can still do better. And there were already some structural support for this kind of knowledge use, but it's lacking, so we could strengthen that for sure. And the main challenges related to conceptual knowledge use are related to knowledge itself. So to try to incorporate these different perspectives and plural views, it's complex, and there's an element of subjectivity that comes into play. And then third of all, we have symbolic knowledge use, and here I refer to purposeful knowledge use with this. So this kind of knowledge use is very aimed to steer action, make change, really reflect critically on our current practices and maybe redistribute power. So quite a different than just applying very sort of fit to context knowledge. And another thing about this, that it's usually a collective effort, so nobody can do this alone, and that's why we also need to have a active discussion to make it actually happen. So there's a lot more dissemination related to this kind of knowledge use. And the expertise needed is very, very broad, and typically we don't have one person that has all the expertise, so this is more of a team effort. At the moment, there's very little to no structural support for this kind of thing, but it's done more on just case by case. And since it is done case by case and it's maybe very difficult to even identify who the expert could be, there's a significant risk for either unintentional or intentional misuse of information during the process of applying it. And maybe the interesting point here is that the main challenges in our material were related to the politicization of knowledge or the polarization of society. So very, very different issues than in the instrumental or conceptual knowledge use, because this is where power comes to play. We have to be critical on ourselves and our values, and that also shows very different things on the challenges as well. So to briefly sum it up, thanks. all of these types of knowledge and contexts of knowledge are essential for sustainability transformation. And all three of these contexts, they interplay with one another and they're not stable. So what may now be symbolic knowledge use can in the future be conceptual or even instrumental. We can learn on things, and the structural support and the sort of routine to do this is vital for these contexts. And my second point is that we can obviously support all of these knowledge use contexts, but in different ways. So the instrumental, fairly institutionalized knowledge use, we can do things such as improve the data quality and coverage, which we have been doing in FAIL. For conceptual knowledge use, we could do more synthesizing research, integrating these different phenomena together, and offer some expert support to actually apply and adapt the information, which is another thing we have already been doing. And for the symbolic knowledge use, we need to facilitate interaction. Also, expert support is a good option, and just to ensure that we have knowledge production that comes with diverse perspectives, so we're not just putting all of our eggs in one basket. That's an essential step there. And then maybe my last point here is to maybe try to create a little bit of hope, so that when we're doing new things, it's often difficult, but when we're doing new things, we're doing transformation. So if you're struggling, if you don't succeed, maybe just consider it that it's a telltale sign of transformation. So it's okay that it's difficult, but it's still important. Thank you.
Hello, my name is Pekka Vanhala, and my topic is demonstrating use of biodiversity data, different kind of applications. This is all about how to increase the benefits from nature data and how to make it visible for public and decision makers. And in this work package, we have 3 different approaches and 5 applications or products. First approach is how to find hidden nature data. And in that, we developed a platform for municipalities to upload their nature data. A second approach is how to visualize nature data. There is this yes, this older version of this. Okay, it's a Luonnontila.fi web service, and Aapo Kahilainen is going to talk about that after this, so I don't go there. And then there's this threatened habitat types in Finland web service and carbon neutral land use and habitat management story map. And third approach is how to meet future demands. And example of that is we developed ecosystem accounting, and we have made 2 ecosystem accounts, and ecosystem accounting will start in 2026, so it's good to prepare. So development of the and piloting a platform for collecting nature data from municipalities. We know that municipalities have a lot of nature data, but it's not easily access to this data, because they might be paper copies or PDF files and so on. And also those methods they collect nature data, they are not consistent. And there's a big demand to have this kind of common platform for uploading all the nature data from the municipalities. And also there's a need for the proper instructions how to make these kind of nature surveys and so on, and then how to record the information from the nature. So for that we choose 13 pilot municipalities which were committed to this work. And first we made a survey what kind of nature data those municipalities have. And based on that knowledge, we made a pilot version of the platform for municipalities to upload their nature data. And in this work we noticed that this geo-information is very, very important. And then we asked feedback from the municipalities how they found this platform and how did it work and so on. And based on this knowledge we made a tentative plan and budget and so on how to carry out this kind of proper platform for municipalities. And also in this case we made some instructions how to collect and record nature data in these municipalities. Second is the threatened habitat types in Finland web pages or web service. This web service includes the results of the second assessment of threatened habitat types in Finland. At the moment, or before, they were published in two very thick books, and now we made these web pages and they are much easier to use. And there's all the information and the same and the books and then much more also. And there's descriptions of the habitat types and distribution maps and photographs and so on. And it's covered of 308 habitat types. Next one is the carbon neutral land use and habitat management story map. And it wants to take the results of the ecosystem modeling into the easily understandable form. That's that ecosystem modeling we heard before the coffee break. And there's greenhouse gas emissions and things from different kind of land use types and human activities, and also the nature values of forests, the old forest and endangered species and indicator birds and so on. All kind of those maps, and we tried to do it interactive, so you can zoom the maps and find more data. Right. And last application or product was development of the ecosystem accounting. We can say that the ecosystem accounting is a statistical framework for organizing ecosystem and ecosystem service data. And it's typical, we have to get all kind of statistical and other nature data from different institutes and sources and form those ecosystem accounts. And we demonstrate the ecosystem accounting with 2 experimental accounts. First was the ecosystem extent account. Basically, it means the what kind of area this is in every ecosystem class, and we measure compare them with between the years. And then the second one was the ecosystem service account, and we focused to 2 things: nature-based tourism, and this is about how many nights you spend in every ecosystem during the year. And then the global climate regulation, and it's about the carbon sinks and fixation. I'll stop here. Thank you.
All right, thank you everybody. My name is Aapo Kahilainen. I'm a senior coordinator at the Finnish Environment Institute, working at the Nature Solutions unit. And I've been working with indicator pipelines and automation of indicators. And bear with me, you're nearly there. There's only between you and a beer or whatever it is that you're going to do after this, there's only Joona. So. I'm probably not lying if I tell that about 90% of the presentations today have mentioned an indicator one way or the other, if not 100%. Maybe there has been a couple of presentations that haven't mentioned an indicator one way or the other. Indicators in biodiversity-related policy, agreements, and planning are quite ubiquitous. We can use indicators to map or to monitor the drivers, for the underlying drivers that then create pressures that then influence the state of biodiversity or nature, and how does then this impact us, our ecosystem services, whatever nature benefits to people that the biodiversity then brings. And then we can also monitor with indicators the responses that the society then does in order to change its behavior to reduce the pressure on the state. So I'm just going to mention briefly here that most of my talk and my work has focused on the state indicators, so things that focus on the state of environment or nature. And all of these indicators, this indicator stuff is very important and very contemporary right now because of many of the recent developments in international agreements are starting to include more and more quantitative targets. And this is true for both national and international agreements and strategies, and most notably the recent Kunming-Montreal Global Biodiversity Framework and its monitoring framework. But it's not only policy and like more of the agreement side of biodiversity, but it's also different indicators are also used in society. So these are Finnish newspaper headlines from a couple of years back. I've been collecting these every now and then when I see them, and these all of these news pieces have actually included some kind of biodiversity indicator data. And it seems that there's an increasing interest in the media to publish and display, visualize data on biodiversity and environment. But the indicators they're not very simple. There are a lot of challenges in using indicators. We have many different strategies, we have many different agreements, and it's difficult to align the indicators that they use. Often they have they might use even similar data, or they might have similar indicators, but then they produce it somehow differently, and this all can turn into a big mess. A large number of indicators also means that it's very difficult to update. It's very difficult to keep things contemporary. And the underlying data is produced by many different institutions, and for a single indicator, you might need to combine a lot of different sources of data, and it can get really, really difficult. Also, the big amount of indicators can lead into a situation where it's very difficult to kind of get an overall image of what is going on with our biodiversity and our nature. Then there's always the balance between simplicity and complexity. So the indicators themselves need to be accurate. They need to describe the exact phenomenon that you're interested in. And they need to be simple for communicative purposes. And then there's often the problem that we need to know what data we have, what can we actually do with indicators, and sometimes, or actually very often, we just have to work with what we got. So we've heard many times already today, so we talked about different dashboards, a single number, biodiversity footprints, very contemporary discussion topic. Many decision makers and politicians, private sector, wants a single number for biodiversity. Then there's the ecologists, conservationists, biologists say, no, we can't do that. This would be misleading. But then there's also a lot of promise with the future. So the general trend in biodiversity data is that it's increasing. It's increasingly open. For example, the Finnish Biodiversity Info Facility has over 51 million observations in its data data portal, and these are mostly openly available. There's one sentence that's unfinished, but the modern survey methods also promise a more effective dissemination or distribution of the data. Also, with Earth observation and modern monitoring methods, the data is more regularly and more frequently updated. And then we also have much more computational methods that are readily available for everybody to use. So it's easy to put up servers to produce indicators. And this all means that indicators can be automized. We already have the tools and we have the data. So I've been working with this Luonnontila web service. So now, just to avoid confusion, so we just heard from Luontotieto web service, and this is a different one. It's a Luonnontila. So the other one is info, like nature data, and this is the state of nature, kind of if you translate it. We just published this in English, so as of 2 hours ago. You can also read it in English. It's not fully there yet. There are still some indicators that we don't have translated. But for our international audience, you can already go take a look and understand what's the concept behind it. But briefly, indicator automation, it goes like this. So that there's a data provider. The data provider has some kind of an open data programming interface, application programming interface, from which our web service, Luonnontila, then takes the data or does a data query to this programming interface, then does all kinds of tricks with the data in order for it to fit a statistical model, and then we produce outputs and visualization out of it. Now this is all fine and simple, and it gets more complex when you actually start going towards the reality of the indicators. This is a simplified example of a real indicator, chemical oxygen demand in lakes, which is supposed to describe the amount of humic substances in lakes. So this is still simplified, but basically a realistic example. And this is in reality what it is all like. So we have all of the different dots here are different data objects, and this is a pipeline that I produced. it's available in GitHub, and we try to publish all of the luonnontila indicators in GitHub, the source code for it. But here, the purple block is the data query part, so the part where we ask data from the API. The blue block tells us all the kind of the tricks we do with the data before feeding statistical models, which is actually the biggest block of the whole thing. And then we actually, in the end, we only have 3 different objects that we produce. We produce an object for the indicator time series, which is here the blue line, then the status of the indicator, and then the linear trend estimate of the indicator, so where it is heading currently. Now this particular indicator, an increasing trend means that it's getting worse, so there's more humic substances going into the lakes and it means that it's turning brown. Okay, so especially the two lower parts are important, so we're gonna get there in a bit. Good, I'm nearly there. So, okay, it's easy to update, but still we're not past from the problem that it's still all very complex. We can update, we have automized, say 100 different indicators. How is that gonna lead us into getting an overall picture of what is going on? Now, it is these 2 blocks here. So the status of the indicator and the direction of the indicator that then allows us to map all of the indicators in the simple 4-field. On the y-axis here, we have the status, and on the x-axis, the development or the trend. And each of these dots here represents 1 indicator. Ideally, we'd want all of the indicators to be here on the green area so that they're either doing good or excellent or satisfactory, and that they're improving or stable in their status. So this is kind of our proposal for your single number in biodiversity. You could be able to choose different environment types. The colors here refer to different major environment types in Finland, for which we have 9. We're using a classification of 9 major habitat types, and you can take a look at each of them individually, or then you can try to take a look at the overall picture. And each of the dots you can click and go through to the website and the actual indicator. And that's where I finish. So, so it's not. So just to say that it's not all me. It's actually originally this Luonnontila site is by Ari-Pekka Auvinen here on the right, and Päivi Sirkki and myself, we've been together with Ape, we've been developing this update and this overall picture stuff. Thank you.
Thank you, and thank you for adding about a minute to our Q&A session. Yeah, questions please. Also, if you have questions about the previous presentations for Ulpo and Ida as well, then now would be the time. Do you guys all want to join me on stage so that it's easier to hand you the mic? Thank you. Yeah, any thoughts about these final presentations, or are you already so much dreaming of that beer that? All right.
Hello, Janika Bori, EA. Thank you so much. I can already see invitations coming your way to present this to IONET and to the broader network in Europe. But the question comes here. Ida, your presentation and Apo, your presentation are both different versions of nature. Do you have already cross-linkages between these? Could we go into what Ida presented, search a habitat, and then find our way somehow to what you just presented?
Yes, we're going that way. So it's already, this Luonnontila is already linked in Luontotieto. Each of the indicators currently are not. So we need to produce metadata for the indicators in order for it to be found directly from the Luontotieto thing. It's a lot of work, but if you have resources, we will do it, of course.
Any other thoughts or comments?
Thank you. Yeah, I was wondering about the, did you call it, symbolic use of biodiversity knowledge. I wonder, Heidi, if you have any ideas about this type of indicators, whether if you see a role of kind of the wider public in producing the indicators, because that should somehow be in the realm of symbolic use of the knowledge. We should involve kind of people outside the expert realm in the work. Thank you.
Well, my short answer is yes, definitely. But transdisciplinary approaches are very essential for that kind of knowledge use. I don't have any very specific example I could give you, but it depends what we're trying to change. So the actual context of where we're applying the knowledge and what sort of information we need, but getting involved and active is an essential part of the symbolic knowledge use and making it broad. And yeah, maybe that's my short answer, yes.
Yes, about using the data. Thank you so much for this. I've been using this luonnontila, but now also luontotilat, and in the future. So as part of the forecast work we do with all the ministries, it has been really useful data, because there, of course, I want that this biodiversity is, all the ministries look for the data, and I try to promote it there. But maybe I have to come back to, because some of the picture, you take some sort of data out, and how can you then, it's not maybe so easy then to use that in some other sort of publication, or then when you have sort of the dashboard or whatever one, it's not like a one, but sort of the simplest picture. Maybe it's not so easy then you have to use it maybe in a digital form. It's a bit difficult maybe to take out and use it in some reports, because you need to go and click and see what's happening there. But of course, in order to use the data, for example, in these kind of purposes, it would be also important to have the pictures in a form that it's then easy sort of to use. Of course, putting reference to your web page, but then maybe it would be more used for the pictures.
Quick comments, please.
Well, I have a question.
Yeah.
A technical question to Ida. You said about the Luontotieto portal, there was the section on monitoring and methods, and you said that there was information on the ongoing monitoring schemes, perhaps something like that you said. Is there information also on previous schemes that have been interrupted? I know that there is, for instance, I think it was Lucas phenology monitoring scheme that was interrupted, but it's still a valuable time series up until whatever year it was. And that could also serve as kind of a gap analysis, or like, to actually pinpoint which things we are lacking. And then a small comment to Heidi. When you talked about the different, levels from data to information and knowledge and wisdom and so on, did you think about the Finnish words? The Finnish word tieto, where it comes from, the etymology of it. Tie meaning road, so it's actually meaning, to know the road, to know your way. So that's quite nicely, it actually covers the whole road from data to wisdom, doesn't it? Such an easy language, Finnish.
It's lovely.
Yeah, to my understanding, there is not information. Päivi can correct me if I'm wrong, but there is not information on like cancelled or interrupted schemes. But that's a good point, that's valuable information also. Yeah, Päivi's nodding.
All right, and Petteri had a quick comment.
Yes, thanks for great presentations again. So my question is to leverage this for this European level or international level. So these solutions, what we have been now tailoring for Finland and demonstrating this kind of search engines and also automated indicator pipelines. So how do you see the possibilities to maybe use these as examples for other biodiversity partner countries which maybe are thinking this kind of establishment? There are some plans for the biodas in pipeline, maybe for the next years, and for this geobond community, that how these kind of automated indicator pipelines could be maybe generalized for whoever might be getting benefit out of them. So do you have some open scripts or anything like that?
I guess this was for me. So, yes, basically the way that the pipelines are being coded is that they're made from different blocks, and the blocks can be used in different contexts. But the problem there is that it is still tailored to the data from which the indicator is produced. So with a little tweaking, yes, and the general concept is, of course, is very usable, and the tools, we can introduce the tools and our approach, but can you just directly take the source code of Luonnontila and use it somewhere else, plug it in? It might take a while to get it working, but in theory, at least, it could work, yeah.
I can comment shortly on this kind of service that we have done with the data search. I think at least we have this prototype now. At least lessons learned is something we can tell other countries that haven't started yet. So this is at least something to give.
Awesome. I know that there are more questions, but unfortunately we don't have time for them because otherwise people will miss their ferries. So thank you so much. Such good questions and interesting conversations to continue for sure. Thank you for all the presenters, and what are they? We're almost at the end of the seminar, but to send us off to our festivities for tonight, this evening, we have Senior Specialist Joona Lehtomäki from the Ministry of the Environment. Joona has been mostly working on the National Biodiversity Strategy and Action Plan and research collaborations, including with FEA. And he's also the chair of the project steering group, so he should know the project very well. Welcome, Joona.
Thank you. And I'd like to start by filing a complaint. First of all, indeed, I am the only person now standing between you and the beer, so I'll try to make it brief. The other complaint I'd like to file is the topic of my talk, which I was given, which you can see here, which is biodiversity and ecosystem observations and collaboration networks in the past, present, and the future. That's a tall order. And we've been hearing a lot interesting things that have been developed and partly put into practice in the context of FEA today. I'm not trying to summarize all that we've been hearing today. I'll try to raise a few points that I think, or I thought, won't be addressed by others. Now, having listened to all of these fantastic talks, I was maybe slightly wrong because many of the points indeed have been addressed, but I'll try to add something on them and maybe put forward a few comments as well. Here's to kind of highlight the point that we've actually covered a lot of ground today. You know this, so I don't have to make a big fuss about it. But I was pretty happy with the way the whole seminar was structured today, which was to also place Finnish Ecosystem Observatory projects in the broader context of not only European development, but also in the context of global developments. And that's important for us in the Ministry of the Environment as well. I'd like to congratulate the whole project, all the people involved in the project on the behalf of the Ministry of the Environment. And it'll be very interesting to see how the work that now has been put in practice and started within FEA will fare in future. Speaking of which, that was the sort of middle part. We heard quite a lot about the actual things that have been achieved in FEA. It was also, for me personally, although I have been following the project quite closely, as was said, I'm the chair of the steering group of a project. I'm also the project sort of overseer at the Ministry of the Environment. So I know the project thoroughly, especially throughout the bills that have been sent to our way. But I believe that it has been money well spent from our point of view and the point of view of the Finnish government and the whole country. But here we are at the end of the day. I was particularly happy with the few talks that we heard just before mine now, looking at the different ways that FAO has actually facilitated in putting nature data or information in practice, and was thinking quite a lot about the connections of the previous speakers with what I'm about to say. At the same time, of course, and again, it's sort of a daunting task to be trying to summarize all of this. But anyway, I'll give it a try, and I'll start with the past part. So I took the objectives quite literally. So I start with the past, look at the present, and then maybe on the future as well. And starting from the past, it may be worthwhile to sort of restrict the past to quite near past, say last 4 years or so, when FAO project actually has been working, and spend a few moments on talking about why the project started to begin with. What was behind the project from the point of view of the Ministry of the Environment, and to sort of lay down a little bit more background on or where we may be heading in the future. So obviously, it's about resources. Resources have been mentioned today several times. More specifically, lack of resources, or at least lack of stability and predictability of resources. And, you know, there's no hiding it. FAO was a significant investment in terms of resources on the behalf of Ministry of the Environment and also the Finnish Environment Institute. And so for the past 4 years, the resources have been pretty significant in terms of putting into practice things that FAO set out to do. However, it's also good to bear in mind that several people today in their talks have mentioned that having sufficient resources guaranteed into the future is another tall order, especially in terms of government budgets. This is something that cannot be achieved easily, if ever. That is to say that, of course, the decision makers have the final power in terms of allocating government budget, and therefore, more or less, we are oftentimes finding ourselves in a situation where we have to accommodate the resources that are available. And right now, as was pointed out by Laura Höjer as well, the resource situation, of course, is rather dire when it comes to the government budget, at least. Lack of access and interoperability was, of course, something that was on our radar as well. I think this is a more of a, let's say, research-orientated and practitioner type of an issue, but it's something that we are very considerate as well. When it comes between different operators, different actors, also within the government, it's important that different data sets are actually interoperable, and we are also firm believers in the openness of data produced with public funding in particular. I think FAO has addressed that pretty well. Now we're getting into the harder territory, which is lack of priorities and inability to change, including different kinds of path dependencies, when we're talking about actual actions that we might take in order to stop biodiversity loss, for example. This is something that FAO has facilitated for sure, but I think it's outside the remit of FAO project to define these priorities, and that's something that needs to happen in the public sphere within the government, and lays, at the end of the day, in the hands of decision makers, as we've heard today several times. I'll come back to this in a few slides. And then there's the lack of coordination part, which I think FAO has actually, again, facilitated quite substantially during its operations, and also coming to future. And it's been, for me personally, very informative 2 days, not only today, but yesterday as well, as I was participating in the Biodiversity Plus and GBIF symposium, where, again, this discussion was taken to international context, and sort of opened my eyes a little bit more on terms of need for coordination in international context as well. So that's kind of like boiling down the different types of problems or lack of certain types of information from the point of view of the Ministry of the Environment. And I think for the most part, FAO has very well achieved to facilitate many of these lackings. Okay, so coming back to present, this is more of a doodle that I'm pretty happy I did in anticipation of these 2 days. I mean, I had to hand in my talk on Monday evening, so I hadn't had the opportunity to actually update this based on what I learned yesterday and today. But it serves to sort of make a point. The point is that there's a lot of different things. That's basically it. That's the point. From the point of view of Ministry of Environment, we of course have different kinds of agenda setting papers and initiatives that I've listed here on the left side of the slide, starting from the international commitments that Finland has committed to, for example, the Convention on Biological Diversity, the EU Biodiversity Strategy, our National Biodiversity Strategy and Action Plan, which is closely linked to the 2 foremost or before mentioned international strategies. But then we have a whole variety of different important government internal strategies as well, like the strategy of environmental monitoring, and for example, the National Forest Strategy, which is closely linked to the National Biodiversity Strategy and Action Plan. So there's the whole level of different kind of strategy and action plan papers that actually sort of steer how the government operates on different levels. We've heard a lot about the international initiatives. I apologize for the people from EBOC. I'm missing 1C. This is kind of like old information. Yesterday I learned that there needs to be a second C, European Biodiversity Observation Coordination Center. Thank you. And here in the middle, I've sort of listed a few initiatives that have been directly funded or steered by the Ministry of Environment. FEO, of course, as said already, has been a big investment on our behalf. There are several others. For example, about 2 years ago, we initiated the Biomon research program. So that's a research program on systematic long-term biodiversity observations. And that will come into an end at the end of this year. It has close linkage to what has been discussed today in the context of FEO, and it'll be interesting to see how these 2 initiatives support each other. There are other big projects like Helmi Habitat Program and Biodiversity Life Plus program that has been mentioned a couple of times today. Won't be going into a lot of details of those. Here on the bottom, just to serve as an example, of course, much of this is based on a whole variety of actual on-the-ground monitoring. I just picked this number from the FEO final report, 86 systematic national species monitoring schemes. That's a big part of how we actually produce the data in Finland. There's a lot more of it as well. And then I'm glad that we already discussed a little today also the involvement of the private sector. That's to say the sort of pull from the private sector, the interest and the needs that, for example, private companies and private sector has. And so I just sort of, again, as a sort of a memory slot here, placed a whole bunch of private sector biodiversity roadmaps on the slide here as well. Because right now, the private sector is very interested in how biodiversity affects their own operations and how their own operations affect biodiversity. So that's one sort of a big new pull for the type of nature data that we have been discussing today. Okay, so not surprisingly, at the end of the day, it's really about people, networks of people, and so what does this actually imply for the future? Now, I mentioned pull. This is my sort of concept of pulling something. But we all know that until now there's been maybe quite a lot of push, especially from data providers, from research community, from government agencies such as ours, in trying to make the case for biodiversity, or the importance of biodiversity and nature data. And I think that's slowly changing now in the sense that we're also getting pull. So we're getting interest from outside of the usual suspects in the Finnish society that in the future will more and more steer, hopefully, the way we collate and present nature knowledge or data as well. And I've been very sort of happy throughout the whole FAIR project that this notion has been also an integral part of FAIR all along. So this is one of the graphics that was produced pretty early on in FAIR. It's not the same one that you've seen already several times, but just to make the point that from data to information to use, yes, that's the kind of typical linear type of a way that these are usually presented. But the more important part in my mind is the one below here, from policy needs to information products to monitoring networks. So it goes to both directions. And that's linear as well, and we all know that it's not usually linear at all. It's just a big mess where these things kind of swirl around. But it's important that it's been part of FAIR, and Heidi was talking about this just now. It's also where I think we should be sort of concentrating more in the next steps. We've also heard today quite a few times about the National Coordination Group for Biodiversity Information, or LUCI. Here I just copied the sort of vision for this particular group. Right now, the LUCI group is established in a sense that we have a group of interested instances, 17 organizations and counting. It's a good thing that LUCI will continue, but it will need more resources. It will need, in my opinion, a more firm mandate on what exactly is supposed to be achieved with LUCI. And I'm fully aware that I represent here an organization that has a significant part in determining this mandate. So this is a more of a sort of a continuation of discussion that we've already been having within the auspices of LUCI Group. And this is something that was, I think, partly covered really well by both Heidi and Abo just before my talk here in thinking about where and how should the sort of collaboration continue within the context of LUCI. This is a kind of conceptual picture that I get a chance to show around every few years. It varies a little in the context where I show this, but I think it does have some fantastic points in it. It comes from Justin Parkhurst from a few years back. But if we're kind of thinking about what we're talking about from policy perspective, we've been hearing about the different needs and uses of nature information or knowledge. And in a way, it's evidence for various actions that we may take, have taken, or may want to avoid. And often at times, and this is a bit sort of caricature, but still, oftentimes we're mostly interested in these two sort of circles here on the left, trying to avoid the pitfall here. Evidence of high quality and systematic and rigorous evidence. Those are the kind of like the gold standard of whatever kind of especially scientific evidence we're interested in it. And this is something that I think is highlighted whenever evidence is kind of being pushed from the research community, and that's very natural. Those are integral parts of good evidence. But it's not enough if we're thinking about good governance of evidence. So by governance, I mean using evidence as part of the sort of institutions that govern the different policies that we may take. First of all, of course, the evidence needs to be appropriate for the given policy concern that we have. This may sound like an obvious statement, but it's not, especially if oftentimes there's a mismatch between the kind of policy actions that we're considering and the data that may be sort of suitable for it. This is something that Aapo was putting in more concrete sort of terms when he was talking about indicators, whether they're kind of like fit for purpose, whether they're useful in the context that people may be interested in using them. There also needs to be kind of stewardship and public mandate for governing evidence. That just means that the organizations involved in governing the evidence base need to have a public mandate in doing so. Most oftentimes this means different agencies of ministries of the government, but it's important that we are involved and that there's a clear public mandate for making decisions based on evidence that may have sort of a big public impact as well, which oftentimes we hope they do. It's a very good idea, of course, to have public representation in decision making as well. This goes into the heart of our public institutions, our governance models, and there needs to be transparency in how evidence is used. In terms of biodiversity information, again, coming back to having not only transparent and open data, but also having transparent and open ways how it's being processed and how it's being actually discussed, beyond just the qualities of the data in terms of what this might mean. The public sort of sense-making part of what does this biodiversity information mean in a given context. There also needs to be public deliberation in evidence-informed processes, and importantly, contestability, so evidence open to challenge or appeal. And this sort of oftentimes seems to be kind of a hard part, especially if we're more expert-orientated. Oftentimes, unfortunately, it feels like selecting suitable biodiversity indicators should be almost left to the experts. It's kind of like a technical task, which it is not, because it actually makes it very tangible what we mean when we say, okay, this is going to be the indicator, and this is going to be, say, the sort of target level that this indicator needs to be at a given year. That's being very quantitative, that's being very sort of precise. And it needs to be open to contestability as well, in addition to all of these different circles here. It's difficult. It's difficult especially if there's a general feeling that, well, does this mean that everything is then relative? That, for example, scientifically sound and justified indicators need to be open to anybody's opinion, whether they're okay or not. I'm not suggesting that, but I'm just saying that if biodiversity information and, for example, indicators based on it are to be used in public policy, there's no sort of sidetracking this. It's an integral part of how we do public policy. Now, this is a challenge for all of us. And we, in the Ministry of the Environment, all of the other ministries and the whole government, of course, have a big role to play in it. I hope that Lukki Group will find the resources it needs in order to get up and running even further in the future. And I'd like to end my little public contemplation here by sort of apologizing to Andrew as well, in a sense that you were congratulating in the morning that now we have a BON in Finland. I don't unfortunately think that we quite have a BON yet, so that's Biodiversity Observation Network. We have a very good sort of a beginning for establishing one, and we have, in my mind, a clearer vision now where we should be headed next. And for that, I again congratulate the FAIR project, and we'll be looking forward to collaboration in the future. And that's it. Thank you for you and the audience and for the attention, and it's been a fantastic day. I really look forward to where all of this is leading us. Thanks.
Thank you. Thank you, Joona, and thank you. So wonderful to share this information-filled day with all of you here today and also everyone on YouTube. The stream is about to end, so thank you. And just a quick couple of practical things just to finish off. The next ferry to Helsinki leaves at 5, and especially those holding an invitation to the official dinner afterwards should try to make it to that, because there will be a bus waiting for you. And for the rest of you, I hope to see you at the after party that starts at Korjaamo at 7. And yeah, on my behalf and on behalf of all the organizers from FAIR, thank you so much for being here today, and I hope they have a really lovely evening.